by now, but due to some changes in her travel schedule, she will join us maybe a little later. And Dr. Kavikumar, who was also supposed to join us for this session, he's not able to make it for some personal reasons. Uh, so our first speaker today is Dr. Krishnan from Indian Institute of Tropical Meteorology, Pune, on the topic climate impacts in India. Dr. Krishnan is a director at the Indian Institute of Tropical Meteorology. He specializes in climate modeling to understand the scientific issues relating to climate change, Asian monsoon, and water cycle. Under his leadership, the Center for Climate Change at IITM developed the first Earth system model from India that contributed to CMIP 6 and IPCC 6 assessment report. He was a coordinating lead author in AR6 Working Group 1 report and a drafting author in the summary for policymakers. He is a member of the Joint Scientific Committee, World Climate Research Program, and the World WMO. He and his team from IITM published the first National Climate Change Assessment Report of the Ministry of Earth Sciences, Government of India in 2020. And without any further ado, over to you, sir.
Thanks. A small presentation. Yes. Yeah. I've loaded it. So, good morning to everyone. First of all, I would like to thank MS Swaminathan Foundation, Professor Jayaraman and Dr. Soumya Swaminathan, chair of this session, for this opportunity. Yeah, it's a great honor, sir. And fortunately, I happened to come to NCCR for another official visit. This coincided and I could make it. Yeah. So the topic, I was asked to talk on climate impacts in India, and so I was thinking what to do, and I agreed immediately on the telephone. I was thinking what should I talk and what should be, and also it is based on media dialogue on climate change towards COP28. So I want to highlight three aspects, our own Indian contributions, what we have done in understanding the global and regional climate change. And that is something we have to mention in the highlight in the COP28 in Dubai. And also say what are our contributions and what are the practical issues we are having. So that is one thing. So, and how to go ahead in the future, given these regional impacts of climate change. So keeping this in mind, I have basically split. It's not moving. Yeah. So I'll be highlighting. First thing is we brought out a assessment report of climate change over the Indian region. Yeah. So one thing is we brought out one of the important contributions is that we brought out an assessment of climate change over the Indian region. This is the report of the Ministry of Earth Sciences. It was led by our team at IITM. And it discusses, because when we are talking about climate change over a particular region, climate change is a global, it's caused by greenhouse gases, mainly the warming that we have seen. So the planet has warmed by more than almost close to 1.2, the latest in 2022. And this warming, now it's clear that it is mainly because of the greenhouse gases like carbon dioxide, methane, and nitrous oxide, which have increased. And but there are also other drivers like aerosols, which are more regionally, which have a large spatial and temporal variations. And it appears that since the mid-20th century, a significant portion of the warming has been reduced because of the aerosols. And but when we are talking about climate change over a particular region, we have to understand that, keep the global perspective in mind. Also, the regional, when you're talking about the regional changes, we have to understand the regional geography, the regional phenomena, and in the regional variabilities to make an assessment of what is the role of the human induced global climate change on the Indian subcontinent. And it presents a historical synthesis of the historical and future projected changes of both the global and regional climate over India based on scientific literature, observations, climate model projections, and published IPCC reports. And it serves as a reference resource for researchers, practitioners in academia and industry and policymakers. Sorry. So this is an open access book, freely available. It can be downloaded. So when we talk about the regional climate change over a Indian subcontinent, we did not want to just restrict it to India. We are calling it as a subcontinent. We have to keep in mind that it has a unique land-ocean geography in terms of the high elevation features like the Himalayas, the Tibetan Plateau, the Western Ghats, the Burmese mountains, and we have the Indian Ocean, the Arabian Sea, the Bay of Bengal. So they are all going to contribute to the regional climate. And this region of the world, one of the strongest features is a monsoon. And there's a very strong seasonal cycle of the monsoon. We have from June to September, we have the southwest monsoon, which brings almost 75 to 80% of the annual rainfall over most parts of India. And then we have the northeast monsoon during October, November, December, which brings rainfall to which we call as the northeast monsoon, which produces rainfall mainly over Tamil Nadu and parts of Andhra Pradesh and peninsular India. So the question is, perhaps this is the strongest regional monsoon in the world. And so we have to ask the question, what are the observed changes, not just the monsoon, the regional climate, what happened in the past, how did they happen and why? So it brings to the question of detection and attribution, and what are the future projections, how they are expected to change in the future. And which actually we focused on mainly on the physical climate system. And this is the regional analog of we can think of it as an IPCC Working Group 1 report. So we had 12 chapters. We focused on temperature over land, precipitation. In temperature, we covered both the mean, the extremes, the heat waves, humidity. Precipitation, we had the southwest and northeast monsoon, mean variability. And as I said, monsoons are also affected not just by, it has its own internal dynamics and also teleconnections, because El Nino Southern Oscillation, once we have a El Nino in the Pacific, which is a warming of the sea surface temperature in the Central and Pacific, normally we tend to get less rainfall, which is already happening this year as well. So it has teleconnections with climate drivers remotely operating, and also the Indian Ocean dipole and so on. And we also discussed about extremes, wet and dry extremes, and what are the physical processes. We also covered the greenhouse gas concentrations and flux measurements, which was actually we are making these GHG measurements in India and also globally. We discussed this, and also the measurement of the GHG fluxes in different ecosystems. We had a chapter on atmospheric aerosols and trace gases. What is the radiative forcing? What are the direct and indirect effects? Indirect effect. So direct effect is mostly through how the aerosol affects the incoming solar radiation, and what are its consequences on the climate. And we can also have indirect effects through the cloud processes. So we also discussed the cloud aerosol interactions. We had a chapter on droughts and floods. We talk about drought indices, links to precipitation, soil moisture, case studies of floods. We discussed the synoptic systems which is mostly during the monsoon. We have and also winter time, we have the western disturbances, low pressure systems, extreme storms. We discussed tropical cyclones, thunderstorms, and sea level rise. What is happening to the sea level due to the warming of the Indian Ocean? What are the regional processes? And thermospheric sea level rise, Indian Ocean warming, ocean heat content changes. Also, we had a assessment of the Himalayan cryosphere. This is something very important. And the 12th chapter on possible impacts and policy messages. So, our approach to the regional climate assessment was, we have to have multiple independent lines of scientific evidence covering the key aspects of the regional climate system, both for the observed and future projected. And distillation of regional climate information or knowledge, which is basically a synthesis of the regional climate change based on peer-reviewed scientific literature, publications, analysis of multiple observational data sets, uh, based on in situ, satellite, paleoclimate reconstruction, reanalysis, and state-of-the-art climate projections, CMIP-5, CORDEX, and we have also used the IITM Earth System model, which we developed in-house, and that's and which contributed to the CMIP-6 and the IPCC 6th assessment report. And we also published assessed from the assessment reports of the MOEFCC, NatCom, HIMAP, and we presented first results of the CMIP-6 projections from the IITM Earth System model. And this is the first climate model from India that participated in the CMIP-6 and IPCC 6 assessment report. This is something we have to highlight that, and we are having plans to go for the 7th assessment also. And we had the review, the report was prepared by authors, review editors, experts from various institutes, not just IITM, research institutes, university, academia, national and international. Yeah, this is a very quick summary. I just want to show that when we are talking about, we are looking at all the components of the climate system. That is the atmosphere, the land, ocean, even the cryosphere. We assess the temperatures. Both the left side shows the observations, right, and the future projections from the IITM Earth System model. We assess the temperature change over India, the precipitation changes over India, and also the North Indian Ocean, sea surface temperature, the sea level rise in the North Indian Ocean, and the Himalayan snow cover. And we also examine how it is going to change in the future. I'll be briefly summarizing some of these things in my subsequent slides. Basically, when we talk about the synthesis of the assessed past and future changes in key climate variables pertinent to the Indian region. So we talked about the warming over India and the Indian Ocean in chapters 2 and 10. If you see over India, the annual mean surface air temperature over India, it warmed by about 0.7. This is until 2018, because that is what we assessed for this report in 2020, which was published. And these trends are largely attributable to anthropogenic activities. That's a high confidence statement. And moisture content also over the Indian region has risen during this period. Again, a high confidence statement. And the mean temperature over India is projected to increase in the 21st century. This is based on the fifth assessment, the CMIP-5 projections. And we used also all the scenario RCPs. We have looked at the 245, which is a kind of medium, and RCP 8.5, which is a very high emission scenario. And so the range could be anywhere between 2.4 to 4.4. 4.4 is very much on the high, because the RCP 8.5 is kind of very unrealistic scenario, at least in the later part of the 21st century. So most likely it is the warming is going to be by end of this, it could be anywhere up more than 2.4 to close to 3 or higher across the different greenhouse gas scenarios. But this is all relative to the average temperature during 1976 to 2005. And the Indian Ocean has also warmed significantly because of the greenhouse gas forcing, anthropogenic radiative forcing, and also as due to the ocean atmosphere coupled feedbacks due to changes in the wind patterns. And the warming in the Indian Ocean is about 1 degree on an average during the period 1951 to 2015, and is projected to increase further. But what is more, the warming is more pronounced. The region is the Himalayan cryosphere. The Hindu Kush Himalayan region, it underwent rapid warming almost at a rate of 0.2 degrees per decade during the last 6 to 7 decades. This is a very high confidence statement. And there are data, especially coming from the Tibetan Plateau and also from the some of the Himalayan stations. And one more point is that the higher elevations, which are typically more than 3 or 4 kilometers, they are showing stronger warming in the Himalayas. And this is known as the elevation dependent warming. It is not fully understood why it is happening. And This is a very unique. So the Himalayan region is warming at a very fast rate. And so this region has also experienced significant decline in snowfall and glacial area in the last 4 to 5 decades. With continuing warming, climate models project a continued decline in snowfall over the HKH uh, during the 21st century. But there's a lot of wide intermodal spread is also there. We have to keep. So there's a lot of variability. Uh, Intermodal spread is there. And one more unique aspect of this region is the many areas in the high elevation Karakoram region, they have actually experienced an increase in the wintertime frozen precipitation. And also which we many studies, some studies have shown that this may be because of the western disturbances, their amplitude is getting stronger and they're dumping more precipitation, frozen precipitation in this region. And with regard to the monsoons, actually, we expect that as due to warming, due to the increasing greenhouse gases, as the temperature warms, the moisture content will increase, and actually the monsoon should strengthen. That is what is expected, precipitation. But yet, when we look at the observational records, we see that since the 50s, the monsoon rainfall over India shows a slight decreasing trend, about 6% or so, and with particularly notable decreases over the Indo-Gangetic plains and the Western Ghats. And using climate modeling studies, we say that this is largely related to the radiative effects of the northern hemispheric anthropogenic aerosol emissions. These emissions are coming from North America, from Europe, China, and also over the Indian region. And they kind of reduce the incoming solar radiation at the surface through scattering and also absorption. And so what we find is that this aerosol forcing has kind of offset the effects of the global warming, leading to reduced precipitation over the monsoon, reduction in the monsoon precipitation during the last 6 to 7 decades. And several studies have shown this. This is a kind of medium confidence statement. And on the other hand, what we find is the frequency of localized heavy precipitation has risen over central India. This extreme precipitation, more than 100 millimeter per day or 150 millimeter per day, several studies have shown that has increased. And that is one of the direct consequences of the global warming, because once the temperature increases, we have more water vapor in the atmosphere. So direct consequence is this heavy localized precipitation deep convection is going to increase. But it's a much more complicated issue when we talk about heavy because it's also circulation dependent. And our future projection is, with the anticipated reductions in the northern hemispheric aerosols, future changes in the monsoon precipitation are expected to be predominantly constrained by the effects of global warming. So we can expect more monsoon precipitation in the future, except the near future can be associated, that is 2020 to 2040, we call it as the near term. There the internal variability can dominate, but in the middle and long term, it's all the greenhouse gas forcing that's going to determine the precipitation. And with the resultant increase in the temperature and atmospheric moisture, climate models project a considerable increase in the mean precipitation, but also the intraannual variability and the extremes are also going to increase. It's not just, so there is going to be more variability in the precipitation. It's not just the mean. And we have an assessment of droughts and floods in chapter 6. During the, since 1950, India witnessed more frequent droughts and expansion of drought affected areas. This is all from the observations. And climate models, they project in the future that monsoon rainfall is going to be increased. And but they also project an increase in the occurrence severity and area under drought, because these are basically related to the variability in the precipitation and increase in the water vapor demand. And as the atmosphere warms up, the water vapor demand would increase, leading to decrease in the soil moisture. And also flooding events over India have increased since 1950 in many places due to the occurrence of heavy localized rainfall, short duration events, and flooding occurrences due to intense rainfall, which is projected to increase in the future. Higher rates of glacier and snow melt in warming world would also enhance stream flow and compound flood risk over the Himalayan river basins. The Indus, Ganga, and Brahmaputra basins are considered particularly at the risk of enhanced flooding in the future. Yeah. So these are some of the important. With regard to sea level rise in the northern Indian Ocean, this is indeed because of the warming of the oceans, the thermal expansion has led to, due to the rising sea surface temperature and ocean heat content, have contributed to a sea level rise. Of course, globally, the melting of the glaciers and the land ice also adds to the water, to the mass in the global oceans. But in the Indian Ocean, it's at least so far, it's mostly dominated by the thermal expansion. And sea level variations differ region to region. In the North Indian Ocean, the sea level has risen at a rate of 3.3 millimeters per year. This is during 1993 to 2017, similar to the global mean. And thermal expansion has dominated much of the sea level rise in the North Indian Ocean. And of course, when you look at global ocean, the sea level rise is also due to the glacier melt. And the thermospheric sea level, that is due to the thermal expansion in the Northern Indian Ocean, in the recent 3 to 4 decades, is also related partly due to the weakening of the monsoonal winds and associated slowdown of the heat transport. So these changes in the monsoon, decadal timescale changes in the monsoonal winds can also affect the ocean heat transport and the sea level changes. Future changes in the strength of the monsoon winds will have implications on the North Indian Ocean sea level variations. Tropical cyclones, this is assessed in chapter 8. Intensity of tropical cyclone, it is related to the SST, the sea surface temperature, heat content. Also, it depends on the atmospheric wind shear and circulation. The assessment is that in the frequency of very severe cyclonic storms over the North Indian Ocean during the post-monsoon season, that is mostly October, November, December, has significantly increased in the past 2 decades, despite an overall reduction in the annual TC activity. And with continued global warming, the activity of very severe cyclonic storms over the North Indian Ocean is projected to further increase during the 21st century. So I thought I will show some assessment, especially on the Himalayas, because this region is very, very important region, because it's one of the strongest monsoons, it's a driver of one of the strongest monsoon systems on the globe. It's a source of 10 major Asian river systems, largest reserve of ice outside the polar region. It's a biodiversity hotspot, and also it has a diversity in culture, traditions, and languages. This is again from our book. And one aspect is that in the Himalaya, the warming is happening at a much faster rate compared to the Indian land region itself. So this is something we have to keep in mind regionally, the rate of warming. And as I said, the high elevation regions of the Himalaya, they are warming at a much faster rate compared to the lower elevations. This is known as the elevation dependent warming. So these are some aspects, noteworthy aspects. And we are also targeting, the CMIP 6 was over. Now we are going into the next CMIP 7. So the IITM Earth System model, we have developed a next generation model. We will be contributing to this experiment also. And this will feed to the next IPCC assessment report. So our plans is that we have made I'm not going to the technical details. We will also be implementing the Greenland ice sheet, with river routing, aerosol indirect effects, and we are going to increase the resolution of the models. And future, we want to also include the Himalayan ice sheet. And so these are some of the plans. So a lot of work is happening in India. And quickly, I just want to say, because I was involved in the 6th assessment report in the in the chapter 8 of the IPCC, mostly working on the Asian monsoons. And this was presented in the COP26. So I just picked some slides. So we have defined 6 regional monsoons. The black contour shows the global monsoon region, which was defined in the 5th assessment report, which is defined as the area where the local summer minus winter precipitation exceeds 2.5 millimeter per day. And some of these areas where you see the stippling, these dotted areas, that was also called as a monsoon in the AR5. But we in the sixth assessment report, we are not considering because the published literature doesn't say whether they are. So that's still a matter of debate. So they are associated with seasonal variations in the ITCZ, but we don't call them as the monsoons. We have these six monsoon regions over South and Southeast Asia, East Asia, and Australia, Maritime Continent, North America, South America, and West Africa. And the general assessment is that the global land monsoon precipitation decreased from the 50s to the 80s, partly due to the anthropogenic aerosols, that is in the northern hemisphere, but has increased since then in response to greenhouse gas forcing and large-scale multi-decadal variability. During the 21st century, global land monsoon precipitation is projected to increase in response to greenhouse gas warming at all time horizons and scenarios, high confidence. And generally in the future, both the Asian monsoon and the West African monsoon are projected to intensify. And so there is going to be a strong east-west asymmetry because of the stronger Asian African monsoons and a weakened North American monsoon. And for the South and Southeast Asia, this is the assessment. The South and Southeast Asian monsoon precipitation decreased since the mid-20th century, the dominant cause being the northern hemispheric anthropogenic aerosol forcing, and the dry north and wet south patterns of East Asia summer monsoon precipitation results from the combined effects of both greenhouse gases and aerosols. In the near term, South and Southeast Asian monsoon and East Asian monsoon precipitation will be dominated by the effects of internal variability, but will increase in the longer term. So that is the main assessment, medium confidence. And these are all some, based on the CMIP6 models, this analysis was done, which shows that over South Asia and also East Asia, the contrasting influence of the greenhouse gases and aerosols on the observed precipitation changes during the 51 to 2014. And in the future, with increased global warming, you can see that monsoon precipitation is projected to increase in the different scenarios. Yeah, so this is the quick summary. Again, I will not go into this. So we can expect stronger monsoons. But one of the consequences, another important thing is the extreme precipitation events are increasing. Over central India, many the rainfall events more than 100 or 150 millimeters per day, they are increasing. This is a big...
How much more time would you?
I'll just take 2 or 3 few minutes, sir.
Yeah, 2 or 3 minutes.
Yeah.
So that we have time for questions
yes,
also.
Sure. Yeah. So this increasing of, but one thing, it's also circulation dependent. So when we look at individual events like the Uttarakhand heavy rainfall and floods, they're also tied with the strong interaction between the monsoon circulation and this was the example where the mid-latitude circulation also influenced. So you can get so you can get daily rainfall more than 400 millimeters per day, 300 millimeters per day. So circulation, how it is going to change. So regional circulation features become important. Also, we have this what are known as metropospheric cyclones, which can give 3-day accumulation, something like 700, 650 over this region of Gujarat and Mumbai and other areas. These are associated with formation of these vortices. So how this is going to change in the future with warming is, these are all important scientific questions. And of course, building to address this kind of, we have to develop early warning systems, which is already in the tropical cyclones. We have done a good job. We are able to predict the tracks of the tropical cyclone and the impact. So the loss of lives due to tropical cyclone, that has come down significantly. That's a big. Still, there are challenges with heavy precipitation, but I am sure in the coming years, this will be taken care. That is one of the important focus, heavy precipitation. I just wanted to, now there is recently there was a Berlin summit, which was focused on it's known as the Earth virtualization engines. There they are targeting it will be an international federation of centers of excellence to empower all people to respond to the immense and urgent challenge of climate change. And they are basically planning to make kilometer scale global projections for the next 40 years. And they will also bring in the layers with the observations and the satellite data and the in situ data. With the climate projections, they also want to interface it with this AIML uh, uh, methods. And this will become a very big opportunity. I think this will also be pushed in the proposed in the COP 28. And from India, few of us from IITM, we participated. I think this will be a very important step for some of these early warning systems. Um, uh, yeah. So with this, I want to end my talk. So thank you. I'm ready to take some questions.
Questions?
Yes.
Start.
Good morning, sir. I'm Disha Shetty. I'm an independent journalist. So when we write a lot about air pollution in Delhi, there's a lot of conversation about aerosols and how that's affecting the melting rate of Himalayan ice and black carbon. So can you talk a little bit about what the media gets wrong, what we potentially should be communicating more?
Yeah, actually, so the melting of when we talk about snow and ice melting, the warming, the temperature increase is one of the important contributors. So global warming has happened. And as I said, Himalayan region, it is warming. And this is largely driven by the greenhouse gases. And so the warming due to the greenhouse gases is contributing to the temperature increase and melt. Now, on top of that, if you add these black carbon and other things, black carbon can absorb the incoming solar radiation. And because of the increased, it can also contribute locally. So, but these are all, but one thing, but the main driver has been the greenhouse gases. That is one thing, that's what. But regionally, this could contribute. So that is my view on that. And also, when we talk about aerosols, it is spatially and temporally, it has got a lot of variations. But greenhouse gas is a well-mixed gas. It has a very long lifetime. And the aerosols, the lifetimes are much shorter. So that's what we have to keep in mind. So greenhouse gas are going to remain for hundreds of years, and they are well mixed. And so their impact on the temperature will be much more profound. That's what and these aerosols are much more short-lived. Regionally or locally, they can have some impact. That is my overall view. But what I was telling with regard to the aerosol and precipitation, in general, the entire northern hemisphere region, it's not just over India or because emissions came also from North America, Europe, Asia. So southern hemisphere, mostly it's oceanic areas. Aerosol emissions from the 70s onwards, they dominated in the northern hemisphere land regions. And after the 80s, late 80s, there was some reductions in there due to aerosol regulation norms, especially in North America and Europe. The air quality improved. And that has also partly contributed to precipitation enhancement over West Africa. That's what the assessment says. So the reductions in the aerosols can improve the monsoon further. So going with that analogy, because global warming is going to continue in the future, and we are going to reduce the aerosols, so it is going to benefit the monsoon, in particular the Indian monsoon as well.
Good morning. My name is Virendra Singh Rawat. So you have already broached upon several topics related to rainfall, and so India is basically an agrarian economy, rain-fed agriculture we follow. And over the last several years, you have also touched upon that there have been erratic rainfall activity and all that stuff. So do you think there is a need for a greater coordination and integration between the scientific community, especially related to meteorology, and the agricultural sector, especially with regard to India? How do you see that?
Yeah, I think it is. Yeah, I agree. Yeah, we need a greater coordination. There's no doubt about it. Yeah. So I think when we talk about the forecasting, there are different time scales we have to keep in mind. So in the shorter time scales, we are basically looking at the tropical cyclones and extreme weather. A tropical cyclone, we have done a very good job. I think the prediction up to 5 days, the skill of predictions are excellent. as I said, the loss of lives due to tropicals. When we compare for example, the Orissa super cyclone in 1999 and what is happening present, I think that's a huge, I mean, but this is not just India. Globally, this has happened due to the improvements in the weather prediction capability. Now, when you go beyond the weather scale, when you go to, let's say, 2 to 3 weeks in advance, these active and break monsoon spells, I think that also models are able to reasonably get it. So now they have predicted this. Actually, they told next 2 weeks, monsoon was very deficient last August. But now they have next 15 days, it's predicted to revive, especially in central part of India. And this is a kind of information that you need for the agricultural operations. So the extended range prediction, we call subseasonal prediction, they are going to be key, and we have to focus on that. And when we go beyond the subseasonal, on the seasonal time scale, things can get challenging. When we are talking what is, so for example, this year we had predicted that it will be normal. Now let us see what is going to, because the development of the El Nino was going on. And El Nino, we know it's going to reduce, generally it has a negative impact. But there was also a positive IOD, Indian Ocean Dipole, which is supposed to increase the rainfall. So there's a counterbalance, and within then you have this Biparjoy cyclone coming, it is going now. So it's a very, very complicated system. So when you're talking on seasonal scale, the problem is even more difficult. So we have to make the seasonal forecast, but from time to time, we have to be upgrading it, updating that depending on how the situation evolves. But the mid and the subseasonal is probably a key. And that is where we, by interaction with the agricultural community, now soil moisture is a very important quantity. How to, because we had this very wet spell in July, and then August was dry. So how soil moisture affects the local air-sea interaction, local feedbacks, especially Bihar, UP, that area has been very deficient. Okay. So having the soil moisture assimilation, both from in situ data and the satellite data, if the models can work on that, what is its impact on the subseasonal prediction? That's where I think there could be a synergy with the agricultural community. So I see soil moisture as a very good link, and to how to improve the skill of the subseasonal forecast, where the meteorological community and the agricultural community could come together. I see that is a good point. And there are opportunities to do that.
So when you say that, when you talk about the synergies between the agriculture community and the meteorological community, so which is fine that the predictions are being done, but would you like to shed some light on, how exactly are these predictions being communicated to the agriculture community? Because there's this gap, because you may be making the predictions, but are the meteorologists thinking about, how to bridge this gap, how to take that information and those predictions to the people who are actually needing it?
Yeah, actually, this there is in the IMD, in the India Met Department, because IMD is the operational center. At IITM, we are mostly a research institute. IMD has a link with all the agromet. They have agromet advisory. They have linked to all the agricultural departments of all the different universities. And this information is communicated also through app. It is communicated. All the people are getting it. Farmers are getting it already. So this has been going on for last several years. So there is a good established link between IMD and the agromet units, and also perhaps even the agricultural departments.
There must be some.
So it's already the mechanism is there in place. Okay. So it is not, I mean, it has existed, it has performed reasonably well. But what I'm telling is, what are the critical areas where we need to focus? I think that's important, where we can leap, go ahead, make a big quantum jump. That's important to see.
Hello, sir. I'm Gaurav from PTI. I have two questions, one follow-up. Is positive Indian dipole a big factor which can compensate or can counter a severe El Nino? Or
yeah, it can.
It
can. So it can. So this time, that's what we are hoping. If somebody was telling me, for every 3%, if you have deficiency, I think by August we had a minus 11% deficiency. So to overcome in 1 month, so if you overcome 3 units of deficiency, So monsoon rainfall seasonal will improve by 1%. So this is what now. So if see our September rainfall improves by, let us say, plus 20%, so we may come to normal. So there's a
Which is unlikely.
small ray of hope, but spatially it won't be uniform, of course. Central parts of India, maybe peninsular part, and also the northeast monsoon will start. So peninsular India and central India can get benefited.
Okay.
And so there is a small hope that we may come less than -5%. I mean, that is my personal hope also. Let us see.
And ECMFW in advance for it predicted that the monsoon would be below normal, while IMD said that it would be below normal, but lower side of the normal, 96, 94%.
Correct.
But ECMFW had already said it would be below 90%, 90%, and which we are seeing now. Are we correct, or is ECMFW correct? First. And second question is, many studies say that the Thar Desert would turn green by the end of the century because of increased precipitation activity. And in Northeast, we have already seen that less rainfall is happening. And so as the water level has decreased, increase in rainfall activity would increase
You
crop
have to
production,
keep the
agriculture
question
production.
short and precise. Otherwise, we
Yeah.
simply don't have the time.
Yeah,
please.
My question is, what would be the overall impact on the food security and energy security, given that water level in the reservoirs in the Northeast would decrease and the Thar Desert would turn green?
Yeah. So one question is whether ECMWF, I think with regard to seasonal forecasting, I think all the models are almost comparable. Because the problem is challenging, as I said, on the seasonal scale, because there are multiple drivers involved, and the regional phenomena itself is very complex. You are talking about, you have so many natural variations on different time scales. It has a unique geographical distribution, as I told you, Himalayas, the Indian Ocean, and then drivers like El Nino, Indian Ocean dipole, and then on top of that, climate change. You are really asking a very tough question, what will happen to the monsoon? So I think all models are comparable. Plus or minus here, that's all. I won't, that is my take on that. Depends on the year. And if it's only an IOD, I think we are pretty much high confidence that we will do a good job. Monsoon is going to be strong. 1961, 1994, 2019, all clear-cut case. And but once the El Nino also comes in between, then things are going to become a bit dicey. Like 97, we were kind of normal. This year also, I'm hoping it will be normal, but plus or minus side. And food security, I think Northwest India, we got good rain this time. So I'm not really, it's not to be too worrisome about the food security and other issues. Yeah.
Two very quick questions.
You will have an opportunity to talk to him in tea break. Only one question, and that'll be the last.
Okay,
We
in
are
that case,
really out of time.
I'll come to the forward-looking bit that you spoke about in the end. You talked about Earth visualization engines, and you said that this could be proposed in COP28. Could you tell us a little bit more about it? Also, you talked about use of AI for that. So can you just tell us what it's about?
Yeah, so this is a big global initiative. So the idea is to have global, it's not just AIML, it is only global climate models running at very high resolution at 1 kilometer scale. Because at that scale, you don't have to include all the subgrid scale physical process to be parameterized. They can be explicitly resolved. And so they're exploring the opportunity whether we can make climate projections using this 1 kilometer scale model. However, local information is also very important. So they want to combine the local information through AIML techniques, and with this high resolution climate projections, they want to provide this as an opportunity as a climate information globally to all the users. So I think it's a very interesting idea, and there are going to be 5 or 6 international centers. This is going to be proposed in the COP, and they're also seeking India's support with MOEF and MOES. Yeah. Thank you.
Thank you very much, Dr. Krishnan, for taking time out, being here for a very important presentation. Just one very quick sort of response to your thing about Earth visualization engines. Predictions at this fine scale and across the globe, these are all things which will have serious economic and other consequences. So who is responsible, and who determines what are the margins of error? These are tricky questions, and they require, I think, careful negotiation. We are also concerned, I think, on the policy side with this idea that we will replace global flux monitoring with local national level inventory making in the GCOS initiative, etc. That is also very problematic, because of the issues of national sovereignty. Some third party decides what your emissions are, and who decides, So I think some of those issues have to be thought through as policy side. We have to be cautious about that. Anyway, so I want to just, that's the slide. Yeah, very quickly, and I swear we are going to do this in exactly 5 minutes. So both the nationally determined contributions of India and its long-term low-carbon development strategy are available on the website of the UNFCCC. And we will also distribute it. I think it is in the Google Drive. If not, that will be set right. So I will not go into the details. But it is very important that the details of this or the highlights of this are understood in a precise way, because these are legally binding in some sense. And these are therefore sometimes very carelessly spoken about in the media. Op-ed writers write whatever they want sometimes. And so at least as media persons, I think care and accuracy on this issue is very important. Otherwise, it really skews the discourse. The NDCs are voluntary contributions required to be declared under the Paris Agreement, but we will be judged. There are no penalties as such, but we will be judged on our performance according to the contributions we ourselves have committed to. So that's the idea of the nationally determined contributions. There's constant effort to undermine it, but nevertheless, for various reasons, this will stand. So it is not immediately going to be uprooted. India submitted first in 2015, and it was updated after the PM's national statement at COP26 in Glasgow. So these are currently the state of the India's nationally determined contribution. So one, to put forward and further propagate a healthy and sustainable way of living based on traditions and values of conservation and moderation. This part was there already. The second part, including through a mass movement for life, lifestyle for environment as a key to combating climate change, was the updated part. I'll speak very briefly about life in just a minute. The second, to adopt a climate-friendly and cleaner path than the one followed hitherto by others at corresponding levels of economic development. Then, to reduce emissions intensity of its GDP by 45% by 2030 from 2005 levels. This is again updated. But please note, and this is often missed, the emissions intensity, so it's a ratio, emissions intensity by GDP. The denominator, the GDP, includes the full GDP, all sectors included. The numerator, the emissions, does not include emissions from agriculture. See, this is something where it should be clear about. I think the experts internationally are well aware of it. Sometimes in our own system, we are not aware of this clearly. So this is very important. The fourth is to achieve 50% cumulative electric power installed capacity from non-fossil fuel-based energy sources. So that precision of the word non-fossil fuel-based is important. It includes hydropower, it includes nuclear, etc. With the help of, and this caveat is important, India has so far not made a point about it, but it can, because we have put it down with the help of transfer of technology and low-cost international finance. So it is a conditional statement. Finally, to create an additional sink of 2.5 to 3 billion tons of CO2 equivalent through additional forest and tree cover by 2030. The baseline remains unspecified. So this is important. However, with reasonable choices of baseline, I think 2005 or earlier, the projections are that we are on track. But please note, it is additional forest and tree cover. Okay. So very often people say, you said forest is additional forest and tree cover. Then, of course, there are three general ones: to better adapt to climate change by enhancing investment in development programs in sectors vulnerable to climate change, to mobilize domestic and new and additional funds from developed countries to implement the above mitigation and adaptation actions in view of the resource required and the resource gap. This is an overall statement of conditionality. This is not insisted upon by India so far in evaluation of its NDC performance, but it can do so if circumstances warrant it. Then, of course, to build capacity, create domestic framework and international architecture for diffusion of cutting-edge technology, joint collaborative R&D. So this, of course, India pays quite serious attention to the question of technology, capacity building, R&D, and innovation. The LIFE is a very interesting initiative which was launched by Prime Minister Modi at COP26 for the first time in a very clear and definite way. The question of unsustainable methods of production and consumption as leading to climate change was underlined. This is, everybody has spoken about it, but no country has made this a point of as a statement in the international arena. They have done it informally outside of formal documents, but not generally. So this, we believe, I believe, is quite important. The wording of it was quite interesting. However, I personally would say that the focus, unfortunately, has shifted again to what we should do in India. So the term mindless and destructive consumption applies perhaps to less than 1% of the Indian population, especially if you compare at global scales. Unfortunately, there is a section of our climate policy making, etc., who think everything that we say internationally we should also do, which is not the spirit of combined and common but differentiated responsibilities or equity. So if you think of the Indian farmer as responsible for mindless and destructive consumption, then I really think that people need a reality check, you know. So, but on the other hand, I think there is scope for still taking this forward and really examining the nature of production and consumption in developed countries, developed societies remains an agenda which civil society, media, etc. have to take up. So India also has submitted its long-term low-carbon development strategy. It's a very important document. It's submitted after the national state COP26. Of course, in the national statement, the big statement, which is not part of the NDC, it is the statement declaration of of the goal of net zero by 2070. Whether it is carbon dioxide or all GHG is not specified. So it lists the key elements of the transition to low carbon development pathways across 6 major sectors. It's an ambitious and challenging agenda. It is based on 4 premises. Number 1, India has contributed little to global warming. It has significant energy needs for development. India is committed to pursuing low carbon strategies for development and is actively pursuing them as per national circumstances. India needs to build climate resilience. And the statement that India needs to build climate resilience is not to be equated with this sort of chest beating about India as the most vulnerable country in the world, etc., which is popular in some circles. That is not the position. That is actually a statement as if we are powerless. It also harms prospects of investment, etc., who will come and invest in a region which is the most vulnerable. So I think the measured and correct way to say it is there in the LTLEDS, and LTLEDS is an acronym from UNFCCC. It stands for Long-Term Low Emissions Development Strategies. This is the language of the Paris Agreement. So India needs to build a climate resilience. So it covers 6 aspects: low carbon development of electricity systems consistent with development, develop an integrated, efficient, inclusive, low carbon transport system, promote adaptation in urban design, energy and material efficiency in buildings, and sustainable urbanization, promote economy-wide decoupling of growth from emissions and development of an efficient, innovative, low emissions industrial system, CO2 removal and related engineering systems. So we have some interest in carbon capture. We cannot close that option. Enhancing forest and vegetation cover consistent with socio-economic and ecological consideration. Then, of course, it covers economic and financial aspects of low carbon development. Each key element is elaborated in 3 dimensions: domestic and international context, current policies and targets, elements of long-term low carbon growth strategy. Actually, it's 4, it should be potential benefits and challenges. It also considers research and innovation, adaptation and resilience, the role of the mission life, which I have already described, and the scope for international cooperation. So I think there are also outside this, the sort of detail of our low carbon strategy, there is, I think it articulates India's foundational principles for its climate policy and climate action vision. It says very clearly that it seeks equity through access to fair and equitable share of the global carbon budget. I have written remaining here, but that is in physical terms. And developed countries must be accountable for their carbon debt, meaning we should be able to access our full share of the carbon budget, either physically through negative emissions, if such technology is feasible, or through monetization of the carbon debt. So yesterday we had discussed this extensively. Claim to fair share of the carbon budget makes clear that India's mitigation is not an invitation to developed countries for free riding. So if I reduce emission and they do not, and we do it thinking that we are doing a service to the world. We are not. It's a, it is a game where there is a trade-off. If the other party does not play ball, then our unilateral sacrifice is simply sacrificing our resources and not anything that benefits us. So this strategic significance of the carbon budget needs to be appreciated, and it is strategic in a very important sense. Proactive low carbon innovation and development is not a choice but a necessity. Unlike developed countries, transition in the developing country context is not immediate decarbonization. We discussed this during the panel discussion on COP28. And our point is, India will committed to the rational use of fossil fuel resources as part of the strategy to ensure poverty eradication, food and energy security, while staying within our fair share of the carbon budget. So Climate Action Tracker can say what it wants as whether we are on track or not, but we are on, our guiding principle is that of the staying within the share of the carbon budget. So research and innovation is important, and progress, of course, will depend on technology development, global economy, and international cooperation. And these are not risk-free. It is explicitly acknowledged in the forward to the LTLEDS by the Minister for Environment. So this is a very quick outline of the NDCs and the LTLEDS. So we have time, I think, for maximally one question. I thought Dr. Soumya would, Piyush, would he find out whether? So I have time for one question.
Sir, what would be the impact of the recent amended FCA on creating the additional carbon sink?
Recently amended
Forest Conservation Act.
I think that relates to, see, there has to be a trade-off. So in the sense that, now, I am not going to get into the details of the Forest Conservation Act. I'm not an expert on that, and that is not something which I have studied in all detail. However, I think the point is that there has clearly, in the context of development, generally speaking, there have to be trade-offs. Whether we can maintain every piece of forest cover or vegetative cover wherever we find it in an undisturbed fashion is, I think, being unreasonable. Where and how we take the choices necessary to alter the existing state of affairs is also not something which is very clear. It has to be negotiated, and it's a societal process which does take, you have to have some way of doing it. And over that, will it be controversial? Will it not be straightforward? I think that's the name of the game. But the question of carbon sequestration is that it is all vegetative cover also aids. And simply sneering that it is forest. See, the point is, do not, and I've been saying this since yesterday in one or two ways, a conservation agenda is not the same as mitigation and adaptation. From developed countries, this is a big confusion. Conservation, you want conservation, we'll discuss conservation. And in fact, they are doing it at the UNFCCC. They want conservation as adaptation. Conservation is conservation. Adaptation is not obvious. If you are trying to conserve it, and global warming will change the ecosystem. You can't do anything about it. Because it will for global warming will be very imposing. So these 2 points, I think, I would say in general with regard to what I have said. How exactly we deal with the Forest Conservation Act is a is a matter of detail, and that's not what I am entering today. So I think we'll stop with that. And since Dr. Soumya has been able to join us, even if a little late, so we thought perhaps you would like to make some remarks on the question of climate change and health, and overall on climate in the Indian context. Yeah, please.
Hello, good morning, everyone. So I don't have a presentation, but I'll share some thoughts, and happy to also have a discussion on issue of climate and health, which I think is not getting enough as much attention as it should. I believe that the major impact of climate change is basically on human beings and their health, and this is why we're worried about climate change, not for an abstract reason, um, but really on what it's going to do to us living as a species on the planet, and of course to all the other species that inhabit the planet as well. And this is why I think the word planetary health is becoming also more and more widely used, because there's this interdependence and linkages between the biodiversity of the planet, what happens to other species, whether they're animal or plants, and whether they are on land or in the marine environment, underwater, and human health. So I can give some examples of some very key and obvious ways in which changing climate impacts our health. But there are many, 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 I think, interlinkages, and it's all interconnected in a way in which it's sometimes very difficult to draw a straight line, between two things. In fact, even from the pandemic itself, we know that there were many reasons why the risk of zoonotic infections is increasing. And partly it is because of the loss of biodiversity and the deforestation, the increasing urbanization that is occurring, and that increases the human chances of wild animals, domesticated animals, and humans all coming into closer contact with each other. And if you look at zoonotic infections, the rate at which zoonotic infections are occurring and the rate at which viruses are jumping from animal into human, mostly through intermediate hosts, is actually increased. And in the last 50 years, we know that we've had so many outbreaks, starting with Ebola, with Lassa fever, which occurs mostly in West Africa. There are hemorrhagic fevers that sporadically keep happening. There's Nipah, there's then Zika, and then, of course, the various influenza outbreaks, including avian flu, and then the coronaviruses, of which we've had 3. And there's likelihood of this happening more and more in the future. So to the point where the WHO is now preparing a list of viral families from which these type of jumps to humans can occur. There are about 26 or 27 different viral families, and that's just the viruses. And then, of course, we also have fungi, we have bacteria, and we have other types of infectious diseases. Clearly, vector-borne infectious diseases, also there has been a major change. We've seen malaria now in places where there was no malaria in the past, because the vector, the mosquito, is able to survive now in places because of warming. And so there is a chance now that these Anopheles mosquitoes can go higher up. You'll start seeing malaria in the mountains, which did not have. And similarly, the Aedes mosquito, which spreads dengue fever, also is adapting extremely rapidly. And I think probably the fastest spreading viral infection today globally is dengue, with more than half the world's population exposed to dengue. And of course, as you know, India is one of the most affected countries. So the vector-borne diseases, there is a linkage because the survival of the vectors, and also the vectors which normally may have been seen in forested areas or something, those are now obviously again expanding into areas because of human contact, more and more contact with nature. In India, we have the carcinoid forest disease, which has been there for a long time and still keeps you seeing outbreaks of that happening. It's also the illegal trade in wildlife that also promotes Um, uh, for example, even after the SARS-CoV-2 outbreak, there was a lot of in-depth, focus on the wet markets, particularly in China and Southeast Asia, where live animals are kept in the market and sold. And live animals include a host of different species, all of which are coexisting together in that market. And therefore, again, the spread of, and in very close and cramped quarters. So certainly there is a much higher spread of chances of spread of viruses between species in such a situation. So infectious diseases is one which is going to change both existing and known pathogens, but also emerging and re-emerging pathogens. And this is why there is a huge amount of discussion now globally on how to handle pandemics. Pandemic treaty is being discussed at the World Health Organization and also at the UN high-level meetings, which will happen in September this year. We'll see where that goes, because that's a political process and we don't know what type of commitments countries will be willing to make. The other big impact of climate, obviously, is heat. We've been talking about warming, and we've seen that happening across the world. And of course, there are extreme weather events, but there are also these prolonged periods of heat or heat waves, which we have been seeing, which occur sometimes earlier than, like last year, we saw the heat waves across North India starting in March itself, that not only impacted human beings, but impacted the wheat production also. So the direct impact of heat on humans is, I think, of great importance for us, particularly since we will have a very large number of people exposed to this prolonged heat, because we have also a lot of people who work outdoors, and the nature of work is such that they don't have the protection that others might have. If you're in an office, you're air conditioned, or you're indoors, or you have access to cooling from time to time, then the impact will be less than if you're an agricultural worker or some other kind of worker. In the cities, it's even worse because of the heat island effect in the cities. So the heat is felt much more in the kind of housing that people live in cities. It means that you get exposed to a very high temperature. And we know that there are certain thresholds of wet bulb temperatures beyond which the human body actually cannot tolerate for more than a few days. So the wet bulb temperatures, there are experts in the room who can explain better, but if it goes, it's the temperature plus humidity, which actually has a negative impact. And in fact, we here experience that a lot in the summer because we have very high humidity levels, coastal areas. So if you have high temperature, high humidity, and the night temperatures do not drop below a certain level, then the human body, and recent data shows that you can actually start detecting changes in the heart rate. And first sign of distress could be that you're sitting at rest, you're not working, you're not exercising, but your heart rate, the baseline heart rate goes high. That means your heart is already under stress. And in such a situation, if you actually have to perform hard physical labor, then there is a very high chance that, the systems will start breaking down. Now, we need much more data. So one of the things I think in the climate and health space is that the data, we don't have a lot of good data collected prospectively long-term on what happens to people's physical and mental health when we have data mainly on post-traumatic stress, or what happens to people after they experience a severe weather event like a cyclone or a displacement or floods. Obviously, then there are acute impacts which occur to people's lives. Those have been documented. But over the long term, what happens to people, say, when they're exposed to this type of heat stress? What happens to productivity? Then naturally that will have an impact on incomes. If you cannot work because of the heat, it's going to have an impact on the family income. So there is a need for more data on these issues, especially from low and middle income countries. And it should be from different agroecological zones and different settings. Obviously, what somebody living in an urban environment, maybe a daily wage laborer, who lives in an urban slum, their experience will be quite different from an agricultural farming family that lives in a rural area. And the solutions could also be a little bit different. So in India, there is a climate health national action plan for changes for the health and with respect to climate change. This is administered by the National Center for Disease Control, where there is a very small team actually. And similarly, there are state action plans. For heat also, after the Ahmedabad heat wave in 2010, when people realized the impact, Ahmedabad city actually, I think, was the first to develop a very good heat action plan. And since then, many states, there are, I think about 28 or 30 states, have developed heat action plans. But it hasn't really gone down to the district and the city level, which is what you need. And moreover, it's not enough to have a plan on paper. You actually need a mechanism with governance, with financing, with team, with clear responsibilities, because it's, of course, the health department has a major responsibility to deal with the impact on humans, but there are many other departments, for example, labor, industries. All of these will need to have rules and regulations around how do you protect your workers, and things like that. And what sort of alert systems will be there? How will things be implemented? They're also, for the last year or so, I think, collecting data on heat-related mortality as well as morbidity. So there are sentinel sites across India which are being asked to collect data, at least for the period of the 4 or 5 months during the summer, on deaths that occur and whether they can be linked to heat, and also illnesses and hospital admissions. So some sort of data collecting mechanism has started. But I think we need more of that. And particularly, we know that in our country, the death reporting and the cause of death reporting is very variable, and it's quite weak in many states. And so you really don't get an idea of the exact cause of death of somebody. So this is why there is a need to put in place a specific mechanism to collect that data. So that is happening for heat. And there are heat action plans. So I think it's a question of how does one implement those plans. As I said, not enough to have a state level plan, but one needs to have much more granular plans. Then there was a question earlier, somebody was asking about air pollution. So the link between air pollution and climate, again, is that it's the same causes. The same causes which generate greenhouse gases are also generating the air pollution, which, as you know, is one of the biggest risk factors for health today. Globally, if you see, 99% of the world's population is living in places which do not have air that is as per the WHO air quality standards, which is a PM 2.5 of less than 5 micrograms. So 99% of the world. But of course, there's a huge difference. And today, if you see, the developed world has done a lot to clean up their air quality, whereas the developing world still faces a very high burden of air pollution. And again, the equity issue comes in, but not just between countries, but even within countries. People who are most exposed will be, again, the poorest, because they live in housing, or they're working in places where they're exposed to highest levels of air pollution. So, and we see this playing out, over the years, we've seen levels of air pollution. So I think this, again, is something which has a very big impact on health. It's often invisible and silent, but it affects not only the lungs, but every organ system in the body. And it's, in fact, data is now showing that even the rates of diabetes that we are seeing, which are increasing, type 2 diabetes. I remember seeing data from National Family Health Survey many, many years ago, which showed that families which used solid fuel for cooking, so that means they were exposed to high levels of indoor air pollution, they were the ones also showing high rates of diabetes. And at that time, it wasn't clear the link. But today we know that probably breathing those pollutants is what sets off the inflammatory responses. So your brain, cognition, especially of young children as well as of the elderly, so neurological system, respiratory, cardiovascular system, as well as diseases like diabetes, and cancer, could be that air pollution is actually a risk factor for all of these. So I think that's one of probably the biggest priorities in terms of our health, and it will have benefits for climate. It'll also have immediate benefits for health, unlike some of the other interventions, which could take decades to actually see impact, like heat. For example, we know that there is no immediate intervention that we can do which will bring down our heat levels tomorrow. But today, if we reduce air pollution even by a few points, we will start seeing improvements in cardiovascular mortality. So it makes huge sense in terms of health, human health, but also for productivity and GDP, and in any way that you calculate it from economic point of view, to actually have a very good program for addressing air pollution. And then finally, I would say that, of course, the impact of changing climate, both in terms of heat, water, etc., on our food production and agricultural productivity ultimately is going to impact our health through the nutrition pathway. And I think that, again, one very concrete area of focus for us, or urgent area of priority, could be on the food systems, the entire food system and chain, which deals with what plants, what we are growing in terms of crops, what are we eating, are we getting adequate nutrition, the whole value chain of storage, of transportation, of having access to a diverse diet, a healthy diet, locally produced, etc. Looking at those supply chains will again help not only in reducing the carbon footprint, because very often you do see that the carbon footprint of our food chain is enormous, but it will also help through, again, providing access to nutritious diet, which again, today, the data from various sources, including the National Institute of Nutrition, show that the majority of Indians are not getting access to what would be defined as a healthy diet. In fact, over 95, 96% of us do not get access to a nutritious, if you look at our 24-hour dietary intake. So there is a huge scope there to improve the access to affordable, quality, and highly nutritious food. So this is why I think a food system transformation, looking at it both from what can be predicted as the impacts of climate change, as well as what we actually need for our own nutrition, would, and it's not just land, but also we're talking here about fish and other nutrients which can come from the marine environment, which we are probably underutilizing today in our diets. So those are some of the impacts, I think, on health. I mean, there are many more, and one can, but I'll stop there maybe to take any questions or comments.
Hello, ma'am. I am Nishant. I am from Climate Kahani. So last year, the University of Ottawa released a report which said that the next pandemic would not be from bats and birds. It would be from matter in the frozen in ice, basically from glacial melting. The next pandemic would be from glacial melting, because there must be some viruses and bacteria logged into it. So how do you look at it? Do you look at it as a certain threat for mankind?
So it's one more threat, I think, that has been proposed because of they feel that there could be pathogens that have been frozen for millennia, and then now with the melting, those pathogens could be released. But then to have a pandemic, you must also have a way of those pathogens actually getting into human beings. At the moment, we don't have populations living in those places, or a lot of animals. But if that changes, and if those pathogens are able to travel, we still don't know. So I think that was just the first initial warning, saying that there is a possibility of this happening. But I think that the possibility of a pandemic from other sources that we are knowing about is much more likely than coming from those frozen. But we don't know. So this is something I think we need more data, more studies.
Good morning, ma'am. So my question is about the cause of death reporting, especially when we cover heat wave deaths. That's something that comes up a lot. And the cause of death reporting in India is obviously very poor. But are there examples of countries that have are also low on resource that have improved their reporting, and what does that even look like? Because so many of the reporting, so much of that reporting now comes from estimates and modeling studies that often are widely off, and then they can be alarmist. So what does it even look like, and how can we get there?
So I think the cause of death reporting is something that would help in many different areas. It's not just about heat or about climate, but really to get a good idea of your disease burden and how it changes over time and what are the differences between urban, rural, male, female, between states. One really needs that data. And you're right that without that data, you resort to modeling. And modeling, we know, has its own limitations because you're making a lot of assumptions. So I think the way to approach it really is to have a plan. It's not going to be rocket science. The problem is that you have people who die in hospital, where you have to have one approach, where the physicians need to be trained in how to report the cause of death. And still there are many people who just write cardiac arrest, which is not really a cause of death. That's just the last event that happens for everybody. So you need to know, and there is a way of reporting the underlying illnesses and so on, the primary cause and the underlying causes. So there's a training that needs to be given, I think, to doctors, all doctors. It should be compulsory so that when they are reporting a death, they use the standard format to report it. So that's in India. I think over 60 or 65% of deaths occur at home, particularly in rural areas. So that's another challenge. Then how do you get cause of death, accurate cause of death reporting for people who've died at home without any medical attender being there? But there again, I think there are ways of doing it by training we have a lot of healthcare providers who are out there in the villages or even others. They need not necessarily be healthcare providers. And the ICMR had undertaken a study actually to do what is called a verbal autopsy, which you can have a short questionnaire that can be administered to the next of kin, where you can actually document it. But that would need to be systematized. It would need to have a process so that every death that's reported, at least the deaths are reported now. But even that, I think there is variability in state to state. And also there is a difference in gender in terms of death reporting. But this is something that actually needs to be implemented well. There are ways of doing it. We can discuss the details later, but it has not been a priority. I was very impressed with the South Africa's cause of death reporting and the way in which also they made it real time and they made it transparently available so that even during the pandemic, one could see what was going on in terms of every time there was a wave with a new variant, you could actually see the deaths also mirroring the number of cases and so on. So then it becomes very easy to, but like I said, it's not only for pandemic or only for heat that we need it. We need it really to understand what is happening to our population.
A little bit of political will maybe also is required.
Absolutely. Political will is extremely important.
Otherwise, there's a hesitation to record too many heat wave deaths.
Yes, exactly.
Last question.
Yeah.
Please, we are out.
Good morning, ma'am. So first and foremost, I want to express my gladness interacting with somebody we regularly saw on TV during the pandemic, the unsparing pandemic, giving snippets about health and those kind of issues. So somebody who has a macro view on climate and health issues. So do you think that now we are talking about global north and global south? So do you think that the agenda about climate change and health, the integration between the two or the interplay between the two, should the countries evolve their own health and climate agenda or some kind of mechanism to counter the negative impacts about that, or it should be continent specific or north and global that you're talking about?
Yeah, that's a good point. And I think there again, there are things which you need a global agreement and global collaboration and cooperation to achieve. For example, pandemics, we know that you need a global approach to it. A country by country approach will not solve it. So there are threats like climate is clearly something that we need a global, for example, the financing facility and so on. But there are many things which need to be done at the national level and at the subnational level. So I think we can't wait to say that let's wait for the global agreements to happen. we need to put in place systems and mechanisms to protect our own people. And clearly, we know what the threats are, and the threats are increasing day by day. And India has the wherewithal actually to implement many of those things on our own. We have the human resources, infrastructure, the capacity, the scientific knowledge, all of that. So I think political will is definitely one thing that we need. And then to put in place, and this is one area where you need the entire population or the community to be involved. It's not something which can be implemented by a government agency alone or by NGOs alone. So you really need the civil society participation. We need much more health education, health literacy, and communication of what are the facilities that are available, what are the risks, how can people. I think Dr. Krishnan mentioned how we've done a very good job of reducing deaths during cyclones. I think that's a very good model perhaps to use to address heat, for example, where there is clear messaging. There are centers where people can go to seek help. Everybody knows what they are supposed to do once there is an alert. So a similar approach could be taken, I think, for heat. But then for the other things, it's a little more complicated, like for infectious diseases, vector-borne. There, I think we need much more data and real-time adaptation to our strategies.
Thank you. Despite the undoubted interest in the topic, we are completely out of time. So please, we will have a chance during tea break if you have other questions. So we will end the session here. Thank you, Dr. Soumya, for just turning up. Just people were, I think, happy. We will have now a group photograph, and then we'll go for a short tea break, 10 minutes, and then we'll come. I know. Short question, short tea breaks. And in any case, your space in the newspaper is also quite short. Yeah. Please. Is everybody back? No, but we still have some people missing. Can we start? Gautam, would you please check outside? Huh? Okay. Before we get into the panel discussion, we'll spend about 20-25 minutes to catch up on the theme which we were discussing yesterday about uncertainty, probability. These are very characteristic of the climate issue, and how do we communicate, or how does it affect especially the media, because it is everybody loves certainty, so uncertainty is uncomfortable. So we'll ask I had asked Dr. Ramachandran, frontline science correspondent for several years, an eminent science journalist, to lead the discussion. So
good morning, everybody. And I thank Dr. Jayaraman, to have invited me to this. Well, I should tell Jayaraman not to keep calling me eminent science journalist, because I've been out of active journalism for many years now. Okay. So I'm no longer a functioning journalist. But he nevertheless invited me, so I came. Well, to start this discussion on the issue of uncertainty in climate change, let me just mark off certain introductory remarks, and then we'll go to the couple of slides I put together. And then we'll take up those two slides which Jayaraman showed yesterday. To know how you people react to the whole thing, and your responses will actually tell us how you would like to plan a story in your newspaper or any media outlet and present it, so that it becomes easier for the public to grasp what's at stake and what should be done. So let me just point out that there is near unanimity. About 95 to 97% of climate scientists agree that human influences have warmed the atmosphere, ocean, land, and and that the speed of changing climate exceeds what can be attributed to natural variability. I mean, this is more or less kind of settled science. In the sense that, of course, this also came out of a whole lot of data of over 150 years of observations. And so if somebody wants to challenge it, the probability of saying that this is not due to, there is no warming and this is not due to, and the speed and the rate at which it's increasing is not actually changed, then that probability is extremely small. I mean, so there are also virtually certain that this warming has been driven by anthropogenic emissions of carbon dioxide and other greenhouse gases, mainly because of burning of fossil fuels. Now, these conclusions, as I said, are based on solid data, okay, from ice cores, tree rings, ocean sediments, and so on. So which actually show you the natural variations in the climate, mainly arising out of, say, for example, the solar radiation variance in its solar cycle, and also volcanic emissions and so on and so forth. But if you take into all that into account, climate change that we observe today, the global warming that we observe today is overwhelmingly due to emission of carbon dioxide and other greenhouse gases. So as I said, in this regard, the science is very much settled. But despite this evidence, climate science also abounds in a whole lot of uncertainties. Uncertainty and error windows, of course, as you all know, is part and parcel of scientific observations and predictive science. And based on that data, if there is data, the error in data, so any kind of prediction that you make out of it will also have that kind of a variance. For example, you already are familiar with a regional kind of prediction over weather, just weather, we're not even talking of climate, of monsoon prediction over a small geographical region like the Indian subcontinent, and how difficult it is to predict exactly what's going on. Now, here one is actually concerned with predictions and projections spatially on a planetary scale and temporally over a much longer period. And there are, of course, the known unknowns about the climate, the atmosphere, the oceans, and so on. But there could also be the unknown unknowns. Okay, so we really don't know what the climate, how the climate is, how the atmosphere interacts with the rest of the Earth's ecosystem. And this ecosystem, as the society has evolved, this ecosystem also includes socioeconomic factors. So it could vary from this. The impacts of climate change could vary from region to region because there are other social factors playing a role in the whole thing. Uh, so why there is uncertainty about knowing the Earth's ecosystem, for example, and their interactions? Because scientists lack the whole gamut of observations that is required to understand it fully. For instance, certain areas could be completely inaccessible for making observations. And then there is inherent observational error because of instrumental limitations. And then there are the limitations of climate models themselves. And measurement errors will feed into them. And obviously, the models will produce somewhat kind of a window of results rather than a range of results, rather than a certain predictive point, so to speak. So if you wish to know what the climate will be at the end of the 21st century, for example, the societal actions on how much greenhouse gases are we going to emit in the next few decades is going to decide what will the climate like at the end of the century. So with these kind of unknowns, to make any definitive statement about how the society will be affected, how the impacts of climate change will affect the society in general, is kind of a hard question for the scientific community to come up with. But just the fact that these uncertainties exist does not negate the fact what one is sure about. Namely, there is global warming, and humans have played a role and are continuing to play a role in that, and a very significant role at that. And there is no place for climate denials. As I said, this part of the science is well settled. So there's no place for climate deniers here. And this is given, and there's no going back on this. So, and this is due to his, as been pointed out many times yesterday, that there's no going back, because this is because of the accumulated historical emissions over the past, since the pre-industrial days. And so what will happen? The temperatures will continue to rise. Ice caps, ice sheets, and glaciers will continue to melt, and sea levels will rise. Extreme events, as this graph shows, extreme events, though were not completely non-existent when the global warming didn't take place. But now the probabilities of extreme events has just increased. If you look at the tail of this curve, the bell curve, the average has shifted, and the probability of extreme events, because the curve itself has become a little fatter, and the extreme event becomes highly more probable than otherwise. So now you have extreme heat waves, extreme rainfalls occurring more often, and probably more intense as well. Of course, you also should bear in mind that a certain threshold, you define a certain extreme event at a particular threshold. And this threshold could vary from region to region. What is 40 degrees for London is not the same here. So what you call a heat wave in India would be completely different from what you call a heat wave in the UK or anywhere else in Europe. So we need to know how to define these things and how to arrive at these things in a changed scenario of climate change. So how does one make the general public grasp the seriousness and enormity of this challenge of making them understand that there is uncertainty in climate change prediction, but at the same time, there is a threat of the impacts of climate change that is staring at one's face. So we must also prepare the society, following the precautionary principle, to use Dr. Bhatt's phrase yesterday, and ensure their future. I mean, how do you ensure your future in the threat of climate change? So IPCC is a global body that the world has tasked to provide not only with a proper scientific understanding of climate change, ongoing climate change, but also suggest ways to tackle it and adapt ourselves to projected changes, the high likelihood events in particular. But around 2012, 2012, when the AR5 report was being prepared, was under the works, the community of climate scientists began to realize that what they are trying to say is not getting across to the public at large, because there was not sufficient climate action being seen around the world. So beginning with the AR5 report, the IPCC started to use the language of scientific uncertainty and the language of likelihood and probabilities regarding prediction, projection, conclusion, or finding. So you will find that the AR5 report is the first one which actually states explicitly what is the likelihood of a particular event and what is the confidence level with which the IPCC committee is making these predictions. So these are the things that they said, how to, this chart actually shows the confidence level depending upon the agreement between the various publications they consider and come to a kind of a conclusion. If there is low agreement between the various publications that is on the table and there is limited evidence for the particular event, then you can see the thing, the assessment, the agreement versus the evidence. The confidence level is low here. Low agreement, low evidence, then medium agreement, limited evidence, and high agreement, limited evidence. Similarly, to go across the table, it shows when there is high agreement and high evidence, quality of evidence, consistency, as well as the amount of evidence that is available, then you have high confidence in actually stating some particular problem, some particular, talking something, making a statement about a particular event. Now, there is a couple of schools of thought which emerged around that time, that whether the scientific community should actually explicitly state the uncertainty prevalent in climate change predictions. It was felt that if you actually say that there is uncertainty, it will be taken, there will be increased mistrust with the scientific community, and you will not be able to goad them into climate action at all. So that was one school of thought. The other school of thought that was that your reporting or even communicating with the public will increase in its credibility if you actually say what scientists actually know and what actually the scientists can say at this point of time, at a given point of time. So they also made this particular choice of phrases to describe the probability with which they are making the predictions, namely virtually certain, when it's the probability for a particular event or a prediction or a projection is about 99,000, 100% probability, very likely to be 90 to 100%, likely to be 100%, and so on. So that is the hierarchy of probabilities, and that is the hierarchy of the phrases that they use. So they also use additional things like, extremely likely, which is 95 to 100, and so on. So this is the language that IPCC started using in their own reports. Now, this also tells us what one must use, how this must be used. Around that time, there were also several surveys in the West, public surveys, which showed that if you actually told the public the amount of uncertainty that lies in climate change predictions, then there was more acceptance of what you're saying, more acceptance of your statements, and increased trust with the scientific community rather than otherwise. In fact, even a survey as late as last year, 2022, done by a couple of scientists in the US, used a sample which was kind of mix of Democrats and Republicans. In fact, the survey form actually asked them to tick off the box saying your political affiliation. And what they found was the results showed that there was bipartisan agreement, more or less agreement in the responses to the questionnaire. So it actually showed that the credibility of your statements increased, and the, the scientific community was being accepted more readily because they're actually being honest about what they know and what they do not know. So in that sense, it increases the credibility of a presentation of a story as well, of a news story as well. If you actually going to write your story, present your story with the case or with the uncertainty known about that particular event or a prediction explicitly stated in your story. I'm not aware of any similar surveys done in India. I think one should take up such a survey to know how the Indian public responds to these kind of uncertainty being explicitly stated to the public. And in fact, we don't even know how the public responds to do they have enough climate awareness at all? Even that kind of survey, I don't think has been done. I believe that IPCC has been conducting on outreach events in all over the world, including India. Between 2018 and 2019, they seem to have conducted as many as 17 outreach events. But I never came to know about it. I don't know whether any of you happen to attend any of those events and find out and know about what happened there and how it was communicated and what kind of responses that they get from the public outreach exercises and how did the public respond. And they have not been published in detail what the findings were. It would be interesting to know what was done in those outreach events. So coping with climate change actually is now boils down to risk management, right? It's nothing, that's the best way of describing what we can do about the threats that we are faced with as a result of climate change. And the underlying risk analysis is driven predominantly by science, but also a host of other factors, the local socioeconomic realities in particular. So with that in mind, a journalist or media in general should begin to understand and talk in terms of probabilities for climate prediction projections, highlighting scientific uncertainty. Since it enhances credibility, it should be explicitly stated. Therefore, one must try and present the story in terms of the relative risks of the potential threats rather than giving a certain certainty about a particular event or impacts from climate change that the society and the government, so that the impacts of the climate change and that the society and the government can prepare for. So with that, I will just project the last slides. This is the one slide that Jayaraman showed yesterday. Is one set of headlines the various newspapers have carried. And this should become, I would give some time for you to go through this. I hope you've gone through it already, because yesterday it was circulated to all the people by email or WhatsApp, I don't know. So now this is one set, and then this is the three heat wave headlines. So, and then there is yet another example. So how do you want to proceed with this?
I mean, let's see if people have comments.
Yeah, so I would like the media people to respond to these kind of headlines. How do you kind of react to these headlines? And what would you do in the same place? And would you have changed the headline in a better way, or? Anybody?
Who will take the lead? Or maybe this is perhaps a little too technical. So suppose we do this.
Yeah.
This is one set. Okay. And this is, where's the other one? You'll have it on your, did you, huh? In the WhatsApp group, I think everybody got this. So there is another set of headline, which we called that disaster spike and you put from yesterday.
Yeah, I have it here.
No, no, he'll open it and come on. We don't have much time, so just quick reaction from people. Very pure instinct for how to pitch it. There are many slides. We have the point is about yet another example. So yet another example I can give in terms of the fact that IPCC proclaimed in 2007 report that Ganga Mata will stop flowing. So this is one practical example of certainty, uncertainty,
Yes.
and how science is communicated to the world. So never trust, even if it is a very credible body, you must examine it with your own type of data sets. So IPCC had to tender an apology, public apology, for putting up such a result.
In fact, this is true of that 30, I mean, by 2030, all glaciers will go.
2035, all glaciers will melt. That they had given a. I am trying to say a little more than this. I am trying to say that Indian Himalayan region has 34,919 glaciers, of which ISRO data says that 87% are status quo, 12% are retreating, and 1% are also on increase. And this is mainly because of glacier interglacial cycle. However, whenever we like to communicate to the press, or however, whenever press communicates to the public, it is as if everything is attributable to climate change and not to interglacial glacial cycles. So these are the other thing that we had in the morning was on black carbon. Black carbon has a lifetime of 7 days. So what are we talking? That it will impact your glaciers. So these are some of the things which
it's mainly from the fact that black carbon gets transported and emitted.
So if you go back to your slide, there was something likely, less likely, more likely, unlikely. Some 100 terminologies have crept in. And these crept in from theorem 5 or 6. This 5. From 5. So see the statistical tool being used to convey something. Now for the public, likely, less likely, that kind of a thing doesn't work.
No, so I said, instead of saying that, give the numbers and probability, you just start talk about the relative risk of some event happening. Actually.
I'm not questioning you.
Yeah,
I'm questioning the way the science is progressing with that kind of caveats. So uncertainty is bound to be there.
Yeah.
But the way you communicate to the world or to your own people in your own country by attributing every single thing to climate change cannot also be a very
the first curve itself shows, obviously, I mean, it's a curve, it's a very curve, it's showing extreme events even in the absence of global warming or climate change. So extreme events was not, but now, it's not something that we, I mean, as I pointed out yesterday about the heat wave in Toronto, what was that? The 2019 heat wave we pointed out yesterday. So it happened. So you will not attribute, but if you get down to actual attribution of a particular event, then you'll be lost in the maze of other things, right? It will be very difficult exercise unless you're going through the whole comparison of predictions before the industrial era and post-industrial era. If actually make a comparison and then see whether a particular detection can be attributed to climate change. So that exercise one is not doing. So what
maybe we'll anyway, we have said enough of this. So participant, who's going to jump in on this? Yes.
I think I would say option A provides a much balanced view, scientifically correct view.
Okay, you are
Option A.
option A.
And before that, we have a few headlines, 1, 2, and 3. Would also like to say that before that, the
what did I-
third last slide.
Rajamanikam, where's the slide, please? So which one? So, okay, here he has a clear preference. Between A and B, he chooses A. Okay?
Because
And
it clearly says that things are happening because of natural variability as well, plus global warming, which is a force multiplier here. But in B, it is more of alarmist message.
which B or C?
B. No, this one is I would go for headline B.
Headline B.
B.
And in
Much
between
more
A and
balanced.
B, you would prefer A.
A.
Okay, that's a definite choice. Anybody else?
One point I would like to mention that it is very difficult for the media to convey the entire. It's a lengthy headline, and we have to give it in few words.
Yeah,
So
but for instance, if the RBI says it is 7.5% GDP growth rate estimate is 7.43%. Media goes gaga over it. And they have no clue, and the public has no clue whether that 0.1% makes any real difference. So their numbers are fine. Or for instance, Reliance fell by 20 basis points, and half the people in the country, I swear, I always scratch my head and said basis points. So it fell by 200 basis points. Everybody says, oh, how nice. But their numbers are fine. So why is it that this number, you are disturbed by having this number? That is our question. Yeah.
A lot of times, I think it's okay. A lot of times we may not be able to use the exact scientific term also in the headline. So I think, let me ask you the question. Can we take the liberty of putting that in the headline and explaining it in the copy? Because there we are anyways going by the scientific statements.
I am not passing judgment. All I am doing is I want to provoke. And I want you to go
No, this
home.
is actually a challenge that we face.
No, wait. Let me get I want to go home, want you to leave here thinking, I don't know what the hell is happening. I want you to go home and then rethink and figure it out. So
Just
I
a
agree
minute,
with
I
you.
have a point to make here.
Yeah. I'll just get, I just as a response, not as a reply. I'm not replying. All I am saying is, well, you have to experiment. So it's up to you to be the one out there who gives numbers. And perhaps there's also a question of a niche, For instance, in economic times, if you are writing on energy, then you would write with a certain level of jargon, which you may not do in the op-ed page of Hindustan Times or something like that, just to give you a random example. So there are possibilities. So I leave it in your hands. Yes.
No, actually, that is precisely the point I was trying to make. What you just said, that when you compare this, the reporting that has to be done on climate with financial news, that is a little unfair because financial news is consumed by a particular kind of reader. And those readers understand when you say RBI says India's GDP will fall by 20 basis points or the rate of interest will rise or fall by 20 basis points. They know exactly what people are talking about. It is not meant for a lay reader. Second, whether it is Reliance or whether it is GDP, the consumers are different. For scientific news, especially if we want to reach it to masses, then that needs to be simplified in a way that explains better to more people and they understand it better, which is the reason why we would try to simplify this. That is my first point. But the only thing I say is that doesn't mean that we get a pass to put out inaccurate information, just that it may not be in the same language that scientists might see us or want us to put it out in. That's all.
Okay,
Because
I have
those constraints come.
I have a response on that. When it comes to Reliance and Reliance shares or GDP, etc., the Hindu puts it on its front page. Everybody puts it on the front page. And there the positioning is as if everybody has to understand it. It's not as if you do it in the business page, that's a different story. But it is not as if the Hindu puts it there because they think that there's only a small community which consumes
No,
it.
sir. Reliance contributes about 2 or 3% of the country's GDP, which is and they have the country's biggest. I'm sorry, I cover this as a company. No, I'm saying that the impact is different. The reason why it's put out is different. It is money, it matters.
That's not what we are.
Yeah.
I know. No, but I just want.
But if it is big climate news, it goes on front page.
Okay,
Undoubtedly.
there is something else I want to add to what you said, and that is, why is it that science always has to say, "Oh, please be simplified"? Why should we not have the literacy necessary in science? Why should we not be demanding on the public in terms of how science is?
No,
So that'll have to be done in schools, not in newspapers. I'm sorry.
That we have different views.
I have an opinion on that.
One is not demanding.
तीनों हेडलाइन में कंक्लूजन कहीं नहीं है। और जो पाठक होते हैं जो वो कंक्लूजन पढ़ना चाहते हैं, इसमें सिर्फ प्रेडिक्शन है जो वैज्ञानिक बता रहे हैं, मगर हमें वो बताना होता है जो उनके लिए हो।
हाँ, तो ये बताइए ना, तो अब वो
ये सिर्फ है कि हीट वेव बढ़ रहा है,
वो जो
तो
हेडलाइन
उस हीट वेव से क्या इफेक्ट पड़ेगा वो होना चाहिए हेडिंग में।
Rajamani, put back the slide.
So
The previous one.
previous one.
हाँ,
अब बताइए ये हेडलाइन सी में आपको क्या प्रॉब्लम है?
बहुत लंबा है, वो पढ़ना नहीं कोई चाहेगा।
Yeah, you can same content.
Headline literally does not mean article के ऊपर. Maybe it is the first.
मगर इसका ह्यूमन पे क्या इफेक्ट पड़ेगा वो तो नहीं ना है।
Okay, that's one point.
हाँ।
That's one point. See, ये बात है कि ऐसे नहीं कि we are giving you a full article. It's just हम एक sentence, शायद वो lead sentence हो या second paragraph का पहला sentence हो, उसपे this is an example. वो एक वाक्य को 3 तरीके से लिख सकते हैं, ओके? लेकिन सवाल आपने जो पूछा उसमें गहरा सवाल यही है, when people demand a conclusion, but the conclusion नहीं है, तो आपका कर्तव्य क्या रहता है?
हमारा कर्तव्य कहता है कि मैं उस चीज को लेके मैं लोगों से बात करूं। ये हमारा है।
आपका जिम्मेदारी ऐसे नहीं कि अरे जो पढ़ता है अखबार को आप जाके उनसे बात कर सकते हैं, आप लिख देते हैं, छप जाता है। आप लिखने के समय आपका जब उसमें सहमति नहीं है या कंक्लूजन नहीं है, तो आपका कर्तव्य क्या बनता है? इसका आपका राइट है।
एक्सपर्ट है उनसे बात करेंगे।
Okay, without getting
just a teaser.
So my only repartee to it, that without getting into specific A, B or C, my repartee would be that it is also incumbent on the scientific community or the organizations under which auspicious such thing takes progress, because how you frame the messaging to the journalist also has a very potent impact on the way journalist analyzes and kind of goes about the story. So no, I'm not trying to counter what you have put out. So this is also happens many a times, because as I told you, how you frame the messaging, how you start the press conference or the interaction with the media has a very potent impact on the understanding of the journalist also, because beyond a point, the kind of understanding that you kind of expect of the media persons, but how you frame the thing, how you communicate, what are the jargons or the words you use. Like for to give an instance, if I use term unique for a person or for an event, and I could also use the word bizarre. So when I use the word bizarre, it would have a different impact on the psychology of the person receiving that message. So that's what my only take is, that it is also incumbent on the communicator to first have a grasp of the situation, and to kind of have a lowdown what is the critical messaging that has to be transmitted to the journalistic community.
Which one would you choose as your headline?
To be very frank, I would not. No. For to be very frank, I would not choose either of these three. I would frame my own, because or on an individual.
Okay.
Maybe I will not choose the entire headline, but I'll maybe take the essence of it. So if you talk about the essence, I think headline B, I would take headline B, and word it in my own
That's
understanding.
okay. That's all you word it. But why do you think second is better than C?
I think that it has headline B also has numbers, but the figures are more assimilable than compared to the headline A, because it goes into the percentage points. No, that's what I said. I will not use the exact words. I will take the essence and word it in my own unique way, whatever you say.
Okay. So that's one part. So at that table, anybody else? You? No, but you don't want a discussion over it. No, because I think that's the problematic position. We are prepared to discuss it. But if a media person says, I will write the way I want, I have a view, but I don't want a discussion on it, that's really problematic. No, tell me what is your take on it. We also are finding out what people think.
Sir, we can request them, give them the opportunity, let them come and define their headline for the same thing. And we can very well see whether a vast difference is there or what.
In fact, I would tend to agree with this what you have put here. So the statement is the following, that A seems to be cautious of A. Let me use the mic. A seems to be too cautious or vague. B seems to be too alarmist or biased and might lose credibility if the predictions turn out to be wrong or exaggerated. And C goes like, it'll be interesting to compare. The Earth has a greenhouse effect that keeps it warmer than it would be otherwise. Actually, I have a problem with that sentence also, but for technical reasons, not for the tone. Humans are burning fossil fuels that increase greenhouse gas concentration. These increasing greenhouse gas concentrations are warming the planet faster than ever before. This warming is already affecting crops around the world, especially in low latitude regions where many people depend on agriculture for their livelihood. That is a arguable sentence. Okay, if we do not reduce our greenhouse gas emissions soon, we will face serious challenges in ensuring food security and stability for ourselves and future generations. Ourselves is, I think, debatable. Future generations, I would agree. So I think I am not averse to version C, and I would agree with you that version A is simply too sort of laid back, it's blasé, it is very sort of casual. We all agree is alarmist, but the last two, 4 and 5, the messages which are there, those I think that is where really the accuracy of the evidence is at issue. So for instance, you might ask, is food security today, what is the impact of climate variability as we see it today on food security? And the answer is very little. So there are episodic losses from extreme events, but those extreme events are not the attributability of climate change is low. And if you look at the food security scene, look at all the variables which are play, the far greater emphasis is on non-climatic factors. But future generations, yes, we all agree on that. So there could be different points of view. There are people who say, yes, today climate change is a threat. I mean, many of us think not also. So that's where the evidence becomes important, the quality of the evidence that you rely on. Or you do what is the standard fallback in journalism, you report both. I mean, there are people who have one take, there are people who have a different take. Only problem is in the climate story, because of the earlier experience with deniers and people like BBC saying equal time for both, etc. Now it has swung, the pendulum, at least in my personal opinion, swings to the other extreme, where anything which is not alarmist enough is, for instance, why should you carry the UN Secretary General's global boiling? Global warming, he is the UN Secretary General, so you can't avoid it. But you would you could spin the headline in various ways where you show that editorially you're not sympathetic to that statement. So these are all possibilities. We just wanted to bring it up for discussion.
So there's just one more thing I wanted to say. You gave the example of financial news and science journalism. So I think we also have to understand our ecosystem still relatively new. Like even with respect to climate change, writing about climate change, science journalist as a concept, and earlier we had in newspapers, health was a separate beat, environment was a separate beat. Now we're able to do intersections of all these subjects. We're able to do it as independent journalists a lot more than we'd probably be able to do in full-time positions. But I've held both, so I say from that perspective. And we're all still learning. We're still at a very early stage in the lexicon, and now most people understand climate change. We've got to that point where most people, even anywhere in the country, will know about climate change. So I think it'll also take time. And with the ecosystem being built and all of us supporting each other and our numbers growing, the communication will obviously improve. So I feel like these are teething problems because we're still early on in that journey.
That's a fair observation. What I'm saying is, but still, I mean, you can, given what we have projected here, make your own judgment and make a statement that which, as a journalist yourself, what would you like to highlight in a
No,
story?
you should put them on the spot. please.
Yeah, I'm just, I mean, that's part of the exercise of growing up in science journalism, that's all.
So for instance, I will just know so that you know where Dr. Ramchandran is coming from. When Fermat's theorem, no? When Fermat's theorem was proved.
Not from us.
Fermat's.
This prime theorem is proved by IIT Kanpur guys.
No.
Yeah,
I'm
it's
talking
from-
about the
yeah.
Wiles.
Yeah, Wiles.
When the Fermat's theorem was proved, and of course it was very big news, but people were struggling to write about it in the media. So there are two sort of very good examples of media coverage of something completely abstract, Fermat's theorem, no? Why is it important kind of thing? So one is a very beautiful document by this science documentary journalist in visual media called Simon Singh. He has a beautiful documentary on Fermat's last theorem.
He also has a very good book on it.
He has a book on it. The other which is among scientists is thought is the best communication of it in lay language, which is also actually is Dr. Ramchandran's piece in Franklin. So that's where the discussion partly is coming from. So anybody else comments? Any? Okay. So if that is so, and so with we'll leave us, we'll stop here with this discussion. So just to say that this is a challenge on both sides, I think, for communicating. On your side, a lot of institutions in the United States or Europe, etc., solve this problem by simply putting another intermediary between the public and the scientific community. And they have their own communications people. There are things like Eureka Alert, etc. Nature has its own, puts out its own feed of any major article. So science does it, the leading journals do it. So that is one solution. But sometimes I think perhaps, certainly speaking for myself, I have always felt very uncomfortable about, especially in an area like climate, where I would feel my responsibility as on a continuum, starting from what I do as a scientist, all the way to the communication. And like, I don't want a driver, right? Like, even if I am not a... Sorry, the filter also. So there are different solutions people see the world over. In the Indian government science departments, we often do not have professional communicators and people, who have the experience to communicate. So the person at the desk, the PS to the secretary or whatever, writes out the thing, it goes through maybe the PIP filter, which is not very much of a filter. And on occasion, it is not understandable, on occasion, not well conveyed. On occasion, simply it creates unnecessary confusion. It did happen with the Chandrayaan launch, but then the media is also very attuned to it. ISRO did a better job of it. So these things vary across the. So climate, we have had, this experience that is still in the making. We have to go ahead and see how it plays out. So let's stop. We'll end with this discussion here. So we'll thank Dr. Ramachandran for facilitating this, and we can move on to the panel discussion.
Good afternoon. we'll quickly go ahead with the panel discussion. Will be chaired by Professor Jaraman. And the broader topic is India and climate change. So first, we would have Dr. Rangalakshmi, who is the director of the JRD Tata Eco-Technology Center, MSSRF. She has a background in agriculture and anthropology and over 25 years of experience in various teams. And her research primarily focuses on sustainable agriculture, climate change adaptation, food security, participatory research, and gender and community development. Welcome you, ma'am. Next up, we have Dr. E.J. James, who is a Pro Vice Chancellor, Research and Collaborations at the Karunya Deemed University, Coimbatore. He is at a BE and MTech from NIT Surathkal and a PhD from University of Calcutta. And he did his postdoctoral work at the Institute of Ecology and Hydrology in Wallingford, UK. And he served as a scientist for 30 years at the Center for Water Resources and Development and Management, CWRDM, and retired as a scientist G and executive director. After that, he established the Water Institute, a center of excellence at the Karunya University. He's also served in KITS as the director of the School of Civil Engineering, Dean of Research, and Dean of the School of Agriculture and Biosciences. Dr. James was instrumental in establishing the Water and Land Management Institute in Kerala and drafted the state's water policies. Welcome you, sir. Next, we have Dr. Tejal. I don't think we need another round of introduction for Tejal, sir. And also Dr. Bhatt is also here. So I'm not going to introductions for Dr. Bhatt also. So yeah, over to you.
Thank you very much. So let's go straight into the panel discussion. We'll make some adjustments. So the World Cafe will do in the afternoon, post-lunch, and we'll just go straight for the panel. Unfortunately, I must take the responsibility for this, that we were not able to communicate with the Secretary of the Tamil Nadu Environment Department, and sort of that fell through the cracks. So we do not have Ms. Supriya Sahu with us, but it's a very active department in terms of climate change. There are a lot of new initiatives, and you can find, in fact, it has got a fair amount of media coverage. So you could take from there. So without ado, we'll start with we have 4 presentations. So the first will be by my distinguished colleague, Dr. Rangalakshmi, on vulnerability and adaptation. So shall we go for 10 minutes, Ranga? Okay, thank you.
Good afternoon, everyone. And so far, we have been discussing about the physical sciences of the climate change. So the impacts, the different aspects about it. We had a kind of an dynamic discussion since yesterday morning. So now when we are getting into the next level of actions, that is vulnerability, how do we understand vulnerability and why we need to understand vulnerability and the adaptation measures. So when we are getting into the next, the important report, that is the IPCC Working Group 2, which is focusing on climate change impact, adaptation and vulnerability. That is the main area, and where they define vulnerability, adaptation and resilience in a particular fashion. That we need to understand the concepts behind vulnerability and how we are leading to adaptation, then from adaptation to resilience. That link we need to bring it here. So here the vulnerability, they always see it is a kind of an propensity or disposition, that is the susceptibility, adversely affected, and encompasses a variety of concepts here. I will explain that in the next slide. here they are mentioning two main aspects. One is sensitivity, that is our susceptibility of the system, our individuals, our assets kind of thing, and the ability to cope or adapt to the situation. So both are linked in that concept of vulnerability. And similarly, adaptation also, I will come in detail later. So the report 2 basically has more than 15 to 18 different chapters, and the important chapters which are dealing with our agriculture development initiatives. One is about water, food, fiber, and other ecosystem services which are very essential. Poverty, livelihoods, and sustainable development. These are all chapters very pertinent to our work, and we need to understand what is going on in those chapters and how it is reflecting the global views, as well as in few part it's the national views also. Then the cross-sectoral reports cutting across the different ecosystems and different geography. So in that also there are few things which we need to understand. One is the biodiversity and the semi-arid tropics and the certification related to land. Those things we need to understand the nuances so that we'll be in a position to understand how the impacts of climate change is making a big difference at the local level. Then the final point is the climate resilient development pathways. They have suggested a few development pathways which came across based on the vulnerability and adaptation in that particular context. So when we get into the definition of vulnerability, so here in AR5, that is there is a shift from hazard focus to risk focus was given in that. So where they have defined hazard, exposure, and vulnerability as a kind of key elements, which is deciding the risk associated with a particular event. So in that context, within that vulnerability, again, they are having two main elements. One is about the sensitivity as well as the adaptive capacity. So these things we need to see how the vulnerability, exposure, and hazard make the system more vulnerable to the different initiatives. When we come to hazard, there are things we have been discussing about, that is the climate extremes, heat wave, changes in the rainfall pattern, drought, or sea level rise. There were many things. Even in morning, Dr. Krishnan are explaining about the different elements of hazards. And similarly, the exposure we need to define at different context. Here, individual people, that is the livelihoods, community assets, environmental services, like that we need to understand the exposure elements in the particular context. And here also the social, economic, and the ecological point of view we need to understand. Then the third element is the vulnerability. Here two elements, as I said, the sensitivity and adaptation are interlinked. Here susceptibility of the system, that we need to understand. Susceptibility of the system, especially in agriculture context, the land, water, so those things are making the system more vulnerable. Then the adaptive capacity, one by the resource itself, another one by the users, that is the people. So here the element of equity, that is basically a gender. Here it is a kind of a cross-cutting one with a class, caste, and other social variables, so that we'll be in a position to understand the concept of adaptive capacity in a much more nuanced manner. When we do the vulnerability assessment, there are different ways or different frameworks according to the local context as well as the need. We used to do that basically to understand the current and potential hotspots where intervention can be initiated, or understand the drivers of vulnerability, accordingly plan your intervention, or the priorities, especially to give a kind of a project which is suitable to that area. So likewise, the objective and the context will decide. I give just an example here. Basically, we are working to see water security or water resource management. So in that perspective, we analyze the vulnerability from 4 different dimensions. One is the climate, water, then next comes agriculture, then socioeconomic. So when we put all dimensions together and understand the vulnerabilities, then we'll be in a position to see how the different geographies or different units have the vulnerability and accordingly prioritize your actions. This is one example. Based on that, we analyze the district level, the Tamil Nadu district, how the vulnerability index was. So this is a helpful exercise to understand which district the state has to give priority on water resource management kind of thing. So second, when it comes the livelihood vulnerability, this is just a case study to understand. And here also we have different indicators related to livelihoods, and especially the sensitivity indicators related to agriculture, because most of rural population with whom we are working is basically small and marginal farmers. Then their exposure to different climatic parameters, then their adaptive capacity, because the resources and assets they have to cope up with the changes. So here also, based on that different variables, we assess the vulnerability, and vulnerability assessment is done at the district scale. So the priority, which district needs to give a kind of an attention, which scheme we could able to get in kind of thing. And such analysis can be nuanced also. Block level you can do, at the village level you can do. When we go further, then you will be in a better position to understand the context and evolve locale specific interventions. That is the main point of vulnerability assessment. And how do we translate your study into a kind of an actionable points. And second comes to adaptation. Here adaptation basically a process of adjustment to cope with the changes, and the changes should be a kind of unsustainable, and over a period of time it should be transformative. So that is the kind of scale with which the adaptation is being carried out in the field situation, and it helps to reduce your exposure and vulnerability to climate change, especially in different natural systems with which we are working. Either it is an agriculture field or it is a kind of a biodiversity hotspots, wherever we are working. So such exposure and vulnerability context through our climate adaptation, we are going to reduce it. Here it has both elements of hard as well as the soft, but we give priority to the soft elements wherever possible. And if it is not get into a point of time where the soft is not working, then the hard is coming. Otherwise, in few places, that is a mix of soft as well as the hard is going on. And associated with it, there is an element which discussed in the AR, the last COP 27, that is loss and damage also, it was discussed associated with that. And here, when we come to the global level, out of more than 188 countries, the 170 countries have developed the plan, but there is a lag in planning to implementation. So that process we need to understand how it is going. And here it is a kind of the efforts. Right now it is going on in different geography, that it is a very kind of an incremental or reactive to the event which is happening kind of thing. Even when we take out our own example, after preparing the state action plans or the national action plans, there are different schemes are coming in, but those schemes we need to analyze. Are they comprehensive? Are they targeting any particular climate risk? So those things we need to understand how these policies are getting translated into action at the ground level. Then this particular report is giving much importance to local knowledge in adaptation. And here also, again, we need to understand at what scale we are understanding the local knowledge, whether it is a gendered or the vulnerable sections. Those people's perspective are integrated into the planning process. Then again, here specifically, they are advocating 3 climate adaptation measures as a kind of unfeasible or effective to deliver the core benefits associated with the particular initiative, whether it is a health outcomes or poverty reduction. So in that perspective, we need to see how far the adaptation technologies have been functioning at different scale. Then the important point, which is again reiterated in the report, is the finance to implement some of the climate resilient measures or climate adaptation measures. That again, it depends upon the national as well as the state planning, how it should be taken it forward. Then again, the implementing measures that reduce non-climatic vulnerability, that should be given first importance, so that the adaptation measures could be in a better position to getting it implemented in the field situation. And as I said, loss and damage arising from climate change is also again recognized, but there is a long way to go to operationalize the concept when it comes to the individual national level. And balancing the financial allocation between adaptation and mitigation. When we analyze the budget, most of the budgets are going for mitigation aspects. Then how far the adaptation activities can be brought in at the local level, because that is quickly related to the livelihood and the food security of the population with whom we are interacting. Then finally, the role of agriculture that we need to integrate. And as a kind of an action point, Indian government has implementing 8 different missions, in which the national mission for agriculture, sustainable agriculture, is main one, wherein different schemes have been operated at the central level as well as the state. Also, they have been brought in several schemes related to rainfed area development, on-farm water management, soil health, climate change. There are many things which are coming in also, that we need to see how at the ground level it is getting or making an impact. So right now there are more case studies are available. You can see how it is getting making impacts at the field level to overcome the issues. When we come to adaptation in agriculture, in morning also we have talked about the early warning systems. Very close to the farming community, the available measures is the climate information services, where medium range weather forecast is available. The unit level is much more precise now. Earlier it was district, now they come to block, and even IMD is planning for the village level forecast. So that brings a kind of an good scope for using the information at the farm level. Then the farm level measures, that is many of the measures which could able to support in the adaptation process, changing in the variety or changing in the planting pattern or irrigation optimization. For example, recent past, there is a good focus on AWD, that is alternate wetting and drying, or direct sowing of rice. So those are all areas which could able to optimize irrigation. So such farm scale different technologies are available as part of adaptation. And the third point is the ecosystem based adaptation, how it can be operationalized. For example, to start with a simple operation of micro watershed. In the micro watershed, if you understand the different terrain, then we will be in a better position to identify activities which could able to improve the natural resources in that particular micro watershed. So these are all just examples from the field where we have been interacting, how the changes have been happening at the micro context, and this should be scaled up at the national or state level, adopting different kind of system and measures. So this is about the micro watershed. Understanding the micro watershed will help us to define different kind of activities in the field situation. Again, the context specific ecosystem based approach, if we can follow, then there is a better possibility to improve the natural resources at the local context. So with that, I conclude there are barriers and limitations adapted to the implementing adaptation. And those things are related to social, institutional, economic, as well as the ecological level. One needs to understand the context-based issues and try to address the adaptation barrier to reduce the gap in future. Thank you so much.
Thank you, Dr. Ranga, for this completely comprehensive presentation in such a short time. May now we will take questions all together or for all panelists at the end. May I now invite Professor E.J. James, Pro-Vice Chancellor of Karunya University. It's a real pleasure to have Professor James here, and with our discussions, we look forward to a more long-standing continuing collaboration between Karunya University and MSSRF, and we hope this occasion will be one way to take it forward. Professor James.
Thank you, Dr. Jayaraman. Now, I take a caveat before I start. The caveat is nothing but all the predictions and all the recommendations for mitigation which people talk about are on the ground of statistics, probability, stochastics, and if you want to say artificial neural network. And so what I wanted to say is that there is nothing absolute about it. It is relative, but it gives you a guideline, that a trend. We will have to always keep this in our mind when we are talking about climate change. This is my view. Now, why I say that is the statistical downscaling which they do to the global climate model and the empirical relationship which they use to find out what is happening at the regional level is nothing but statistical. Now, dynamic downscaling which we are doing to integrate the regional models with the global models are also statistical, are also prone to various corrections. 3, we bring in probability to the area of risk assessment by giving it a scientific color. It's again statistical. Then finally, there are uncertainties which we were talking about. What we do as a civil engineer, I'm telling what we do that when uncertainties come, we don't define definitely that this is the thing. What we do is that we create different scenarios and say that this scenario, this will fit into. But when that scenario is going to take place, we will not say. So this is something on the lighter side. I thought that I'll tell you before I go into my presentation. Now, this is what the United Nations has been telling. Sir, if you can give me a hand mic, I think it will be better for me. This is what the United Nations is talking about, the connectivity of water. You know that the topic given to me by the responsibility given to me by Dr. Jayaraman is to talk on water and climate change. It's a big area. Now, water connector, if you ask me, in the light of global commitments adopted by the United Nations, there are 3 important things connected with water. One is Sustainable Development Goals, in which you have got the clean water and sanitation. And Sustainable Development Goal 13 on climate action. This is one commitment of the United Nations. The next commitment is climate change, Paris Agreement. You have got the water connector. The third commitment is disaster risk reduction. This is Sendai framework. Sendai is someplace near Kyoto, where they had met to find out the framework for disaster management. Next one, we can go. Sorry. Now, this is a Sendai framework, which you can say the reductions and the substantial increases. Let's not dwell upon that for long because our time is limited. Now, what is happening? Physics I'm talking about. What is happening when we are talking about climate change to water? You know that when there is more heating, there will be more evaporation. And when there is more evapotranspiration, the hydrologic cycle is intensified. And when the hydrologic cycle is intensified, there will be more storage of water in the atmosphere. Dr. Krishnan is not here, I'm safe. There will be more water stored in the atmosphere, and the precipitation pattern, the frequency and the intensity of precipitation pattern will change, and the spatial and temporal rainfall may change. Okay. Why I use the word may is, I myself am not very sure how much it is going to change. Okay. Now we go to the, okay. Now we go to, this will have, whatever I have told you so far, will have an impact on regional, river basin and watershed, water balance. And changes in magnitude and timing of runoff in the rivers. When all these are changed, the reservoir storages are going to get affected. And your hydropower generation, your irrigation, your drinking water are all going to get affected. Even Pundi Reservoir, which is supplying water to you. And water supply, irrigation, and hydropower will get and changes in soil moisture regime, rate of infiltration, and groundwater recharge. All these are going to be affected by this. Why I wanted to say this physics is, the predictions are based on this physics. And multiple year droughts to affect water systems which are already affected, both quantitatively and qualitatively. And small islands and coastal Lakshadweep, Andaman Nicobar, they are going to be drowned. Some areas will be getting drowned because of the sea level rise, and the intensity, the changes in the extreme hydrologic events are going to adversely affect these islands. Adverse impact on, Somia is not the adverse impact on water quality and growth and spread of water-related, waterborne diseases. And finally, more algal blooms. I don't know what is going to happen to our coral reefs. It's okay, no problem. I think I'll be more comfortable with all that. Okay, now we go to the next. As far as India is concerned, where are we bothered? One thing which we are bothered about, rice and food grain. Professor Swaminathan is not here. Very good. Rice and food grain, which is the backbone of the economy of this agrarian nation called India. Whatever you talk about industry, self-reliant India and all that, I don't believe in all those philosophies. It is my freedom as a scientist. Okay, I don't believe in all that. Okay, now glacial melt, you know, it is going at a few meters every year in the Himalayas. And if this is going to happen, the snow melt will not be there, summer rainfall will not be there, summer flows will not be there in Indus, in Ganges, in Brahmaputra. And, but sir, North India will be in trouble if there is this deglaciation. And there is one more consequence to it. What will happen when it is, I had the data of one of the rivers of Indus, and it showed very clearly that there will be more and more flooding in Kashmir and more flooding in Punjab, because this deglaciation, when it is intensified because of the warming, there will be. Okay, we will have to look into the social problems also. So sea level rise and its consequences on coastal communities, cities, and ecosystems. My concern is what will happen to Point Kalima? What will happen to Webanad cold wetland system? What will happen to, these are some of the systems which we got approved by the Ramsar Convention, and what will happen to it if the sea level rises? Will they be there? Biodiversity be there? This is something which you'll have to look into. Frequent summer cyclones. This has been almost predicted. They are very clear on this. When there is warmth in the sea and when there is more atmospheric moisture content, these are energizing your cyclones, and it will be more. They say that not the number is more. I'm wrong on that. Number will come down, intensity will go up, and you will have a lot of rainfall in Chennai and a lot of floods in Chennai. Be ready for that. I'm ready. In Kerala, I can face it. You be ready for Chennai. Now, what are they talking about? The precipitation status? I don't want to quote this much. Gradually increase in the present century. Changes in average precipitation not to be uniform. Warming high latitudes to experience more precipitation. For example, in North America and Northern Eurasia, you will have more rainfall. And in the mid-latitude and semi-arid, Coimbatore, Chennai, you will have more dryness than rainfall. Okay, now that's fine. Sir, you can stop me at any point you want to stop me, because these scientists are a dangerous species. They go on talking. I don't want to say about this because I have already talked to you about that. Now, complexities and complications in flood and drought management, if you talk about in India, vastness of the country, each region is specific. You've got the humid tropic, wet humid tropic Kerala. You've got the semi-arid Tamil Nadu. And you've got semi-humid Himachal Pradesh. And you have got arid Rajasthan and part of Gujarat. So India, these things are not going to be very easy the way we are talking about. We can have little vagueness. I'm telling this to my friends in journalism. We can have little vagueness. I'm not against it because we ourselves are not absolute. When I publish a paper, I always come with a caveat in my discussion. I'm not very sure about the whole thing. I admit it because I not admit it. Because when I'm not sure, I will not admit it. Otherwise, I'll be telling a lie to the future generation, for which the future generation will kick me. Please remember this. We cannot tell lies to the future generation. I can tell lies to you, but not to the future generation. No, don't tell lies to children. Okay, this is a moral lesson I thought that I'll share with you. Okay, risk involved in generalizing the solutions. We cannot generalize what is there for Kerala model. We cannot generalize it for, and what is for Maharashtra, we cannot have it for Andhra Pradesh, and Andhra Pradesh cannot be there for Orissa, where they're used. Already you have been telling about food security and the economy depend on the monsoons. This year there was a dry period in some parts of the country. In the southwest monsoon, 70% of the monsoon should have come. It has not come, and it is going to affect the food grain in the country. The climate variability has already affected the livelihood of the people. And a climate change, what will happen? Already we are crying. Okay. Now, India's intended, already it has been told, but just one or two things only I wanted to say. We are talking about more hydropower instead of fossil fuels being burnt. This is a commitment of the Prime Minister. Full implementation of Green India mission so that there will be more absorption of carbon. And redesign National Water Mission and National Agriculture, Sustainable Agriculture Mission, which will ultimately give adaptation, robust adaptation strategies for agriculture, water, and health sectors. These are all connected to water. And to implement these actions, by 2030, India requires only USD 2.5 trillion. Where is it? Any projection for this? I have no idea. I don't understand what is this trillion, first of all. I can go up to million. More than that, I cannot imagine. Okay. If you people can understand what is 2.5 trillion, you tell me that. Okay. Some model studies in the context has been done, which has attracted me, which I will not say that you need take it as the final word. One is the World Bank has been studying. I want 3 more points. Okay. 3 can be 4, not. Okay. World Bank study for Maharashtra, Andhra Pradesh, and Odisha. What they used was that a climatic model was coupled, climate change model was coupled to a hydrological model, and the hydrological model was coupled to an agronomic model. And they had a local model, standalone model in the local areas, custom-made model to find out if there is a change in agriculture, what will happen to the economy of people? What will be happen to the livelihood of people? These 3 models I liked very much. And my colleague, he was my earlier colleague, Shashindran, had done a study on Kerala. And another thing Deepti Singh has done in nature climate change. And we have got statewide studies carried out by, okay. Now, what are the findings of these studies in Andhra region? Andhra region, the temperature will go up by 2.7 to 3.4 degrees Celsius. Rainfall is going to increase only by 20% or so within 25 to 30 years time. It is going to be very less, and marginal farmers will have to go for something else. We'll teach them software, or they will come to journalism. We'll try them because we don't want them, marginal farmers. So you will become jobless, is it? So we don't want them. Let them remain there. Okay, fine. So we have to find out something for the marginal farmers in Andhra Pradesh. And those who are in wetland farming may have to come to dryland farming, groundnut and things of that sort, which will bring down their economy, bring down their returns. And larger farmers in wetland crops like rice can continue, but no sugarcane business anywhere. It will not work. So these are some of the suggestions. In Andhra Pradesh, in Maharashtra, it is a better picture. In spite of the fact that the temperature may go from 2.4 to 3.8, there will be, the predictions using the models say that 20 to 30% and rainfall increase. This 20 to 30% rainfall increase will give them better crop production. Then, especially in Marathwada region, better crop production. And however, those who are in sugarcane may have to have a shift. Third case, sir, I will finish it up. Just I thought that some of this will give them an idea. These are drought management strategies. I need not tell you, you can imagine what is to be done for drought. And in Odisha case study, they have found that they're going to have floods and floods of high order. And in India, there is an increasing trend of floods. You have seen what in Chennai, I have seen it in Mumbai, I have seen it in Kerala. So this tendency of floods are going up because of the cyclonic action. So Orissa already the yield has gone down. People are finding it difficult. And you know that what they're doing now. In Mahanadi, you have got the Hirakud Dam, which Panditji said that this is the temples of modern India. Now what they're doing, they're cutting open the sluice gates, more sluice gates they want, because the flood capacity is going to go up by 75% than what it is designed for. So Orissa is going to have a lot of floods, and they're happy with it. Because they're preparing for that, not that they're happy with it. Flood management strategies, you know, Dr. Jayaraman knows it because we were together in Kerala at that point of time doing something, but we have not succeeded in doing much. Whether he agrees with me or not, this is what is going to happen to Kerala. This is something which 1 minute I'll take. You know, ecosystems, your point Calimar will not be there. My study, published. Okay, point Calimar, most of your mud flats will be underneath if there is a sea level rise. Okay, most of your cities will find it extremely difficult because of the flash floods. And riverine ecosystems and the biodiversity is going to dwindle. And coral reefs will get affected by algal bloom. And Himalayan ecosystems will undergo drastic change because of deglaciation. There are pockets of wetlands, there are high altitude wetlands, but some high altitude wetlands, about 2,600 meters above mean sea level, is going to get affected. Okay, now I come to the last slides. Strategies and policies, institutional mechanism, demand side. Okay, this is United Nations Waters Conceptual Framework, which you have got here. And this is the 4 fundamental dimensions of water governance, guidelines for coping up. Don't bother about it. One thing I just wanted to tell you. Have clear communication with the real water. That is where the media can help us. Okay, clear communication with real water users on the impact and the actions that can take to conserve water and protect water supply. This is, we want all of you to do it for the betterment of the world and humanity. But there are certain lessons to learn. Do not consider climate change as a factor when it has no influence. On everything, whatever happens, we say climate change. Don't allow scientists to say that. Don't allow you to say that. Okay. Do not fail to consider non-climatic factors having greater influence. population pressure. There are a lot of other things which are happening. Reclaiming the ecosystems, these are all happening in here also. Do not fail to consider climate change when it is the most important influential factor. Thank you. Thank you for saving us.
Thank you, Professor James. The next speaker will be Dr. Tejal. You want to speak from here? That's fine.
So since this was a panel, I don't have a presentation. And it is really difficult to speak in 10 minutes. How much time? Less than 10 minutes. 5-6 minutes on something like energy. I won't even be able to cover one energy technology. So I'm not going to go there. I'll just sort of some broad highlights and maybe picking off from where the previous discussion, the discussion before this session ended, about numbers and whether numbers should be in the headlines, etc. I remember just before Paris, early in the morning, Jayaraman called me saying, have you seen the newspapers? NDC is out. And the newspapers said, almost all of them, 40% of India's energy is to come from renewable energy by 2030. And I had a heart attack. Those were numbers related to energy, the energy sector. Nobody understands what it means, 40% of India's energy to come from renewable energy by 2030. It was a wrong headline, but almost all newspapers carried it. Of course, once we went and Jayaraman was also quite alarmed, saying, is this what we are committing to? Is this what we are pledging? And of course, we looked at the NDC, and the NDC is worded very differently. It was 40% of installed capacity in the power sector to come from non-fossil fuel-based energy. So there are two key differences there. One was that it is not energy, it is installed capacity. The other is it was not renewable energy, it was non-fossil fuel energy. And that makes a huge difference. Whether it is installed capacity or energy makes a huge difference. And this was also true. The Prime Minister at Glasgow made a political announcement. Right? And that had to be translated to what an updated NDC would look like, India's updated NDC. And of course, there was also discussion at that point of time in the media about whether this should be 50% of electricity or whether it should be 50% of installed capacity. The difference is that if I install a 100 megawatt plant, right, that's the capacity of the plant. But that plant might not generate electricity all the time. Especially renewable energy plants do not generate electricity all the time. You have something called a capacity factor of a plant, which tells you for what percentage of the time in the year will the plant generate at maximum capacity. Typically, solar capacity factors, we assume them to be around 20%, but in the field, you get far less very often. You get around 16 to 17% capacity factors. So 16 to 17% of the time, solar plants function at maximum capacity. Right? And of course, that's because 12 hours in the day, they're not available. The remaining 12 hours also, it depends on cloud cover. It will depend on early in the morning. So when you have light, the rate at which solar electricity generation ramps up is quite rapid. As the daylight dawns and you have increasing amount of light, and then of course reduction over a period of time till the evening. But 16 to 17% is what you get. For wind energy plants, the earlier wind energy plants that are situated on good wind sites, they get around 22 to 23% capacity factor. Newer plants, newer sites, slightly low wind factor, even if these are taller turbines than you had in an earlier time period, slightly lower capacity factor. So you don't have electricity all the time. So to say that 40% of India's electricity supply will come from renewable, and renewable in India is defined without large hydro typically. we use hydro as part of the nomenclature when we talk about renewables, but the Ministry of New and Renewable Energy doesn't include large hydro. It includes small hydro. So typically, non-fossil fuels is the nomenclature that includes large hydro projects as well. Large hydro is anything about 25 megawatts is large hydro. Anything below that is small hydro. You have micro hydro, etc. as well. But that aside, so when you say 40% of installed capacity, it means if India has an installed capacity of 200 and whatever 300 gigawatts today, 40% of that, or 50% now, as per our updated NDC, 50% of that capacity by 2030 will be from non-fossil fuel based energy, which is wind, solar, biomass, hydro, nuclear. Basically, these are the 5 major non-fossil fuel energy sources, right? A large chunk of this is hydro, large hydro. That constitutes a large proportion of India's installed capacity, but hydro is not growing at the same rate. The announcements that have been made are not really to shift from, and I would disagree a little bit with Professor James here. It's not to shift from coal to hydro, it's to shift from coal to non-fossil fuels. While hydro is a large proportion currently, the growth of hydropower is not as fast as the growth of other renewable sources, which is largely it is solar. Even wind is not growing as fast, but faster than hydro or nuclear. And solar is the fastest growing capacity. Right? So, I just spoke about the fact that these are what are called infirm technologies, infirm or intermittent technologies, which means they are not available all the time. If you look at fluctuations in energy supply, small fluctuations happen in wind much more, right? You get a very, it's not a very smooth line of generation. There's a lot of fluctuation because there's a lot of fluctuation in wind. So you have a lot of fluctuation in wind plants. Solar is a little smoother, typically the curve of solar, and it looks like a nice bell curve. You have increasing electricity generation and then decreasing throughout the day. If you take the 24-hour curve for solar generation, it looks like a nice smooth bell curve. So when the electricity is available from these plants, what do you do with other plants that you may not need? If you can, you shut them down or you ramp them down. But you use solar and wind when they are available if you do not have storage capacity to store electricity. Because solar is not available in the evening. Wind typically is much more available in the night. So you have a problem of demand-supply mismatch. Demand of electricity is lowest in the night when you have most of wind. It's lowest in the afternoon when you have most of solar. Right? The peak demand typically happens in the morning and in the evening. There are 2 peaks that any state or any distribution utility sees. One in the morning, one in the evening. It depends on what your consumption mix is. If you have a lot of industry, for example, you have a much smoother demand curve because you have a constant demand for electricity. If you have a lot of commercial enterprises, you have a morning peak suddenly because as offices begin, and you have an evening peak if you have a high residential demand. Right? So every state sees a different demand curve. And therefore, every state's supply curve is supposed to respond to this energy demand and has to have a different mix depending on what that state's demand curve looks like and what that state has in terms of resources. That's why electricity is a concurrent subject, actually, because the state plays an important role, but all resources that are needed to supply electricity are not available with any one state. Right? All of our coal, for example, is concentrated in the eastern part of the country, whereas most of the renewable energy resources are in the western and the southern part of the country, right? Both the wind and as well as solar energy sources. Currently, the highest capacity for solar and wind together without hydro is in the southern region. And if for hydro, the highest is in the northern region. So you have this varied mix. We have what is called a national grid. So theoretically, it is possible to transport electricity from where it is generated to where it is required. And you do that through corridors for coal electricity, for example. Most of it is in the eastern region, through pithead, what are called as pithead plants, which are plants based in the mine. Coal plants that are located very close to the coal mine are called pithead plants. So from there, you would transport electricity out to where the load is, where the demand is. But there is a limited capacity to do this. You need much more transmission capacity if high amounts of energy have to be transported from one end to the other. And this doesn't still solve the problem of the fact that solar is not available anywhere in the country in the night, right? So it's not as if it's available someplace and it's not available in another place. It is not. So you'll have to deal with the problem of storage. We will have to deal with the problem of storage. And currently, it is the grid that performs the role of storage. So we have what are known as non-curtailment policies for solar and wind. We also have non-curtailment policies for nuclear. So when there is generation from these sources of energy, all distribution utilities that have a contract with these plants must absorb all of this energy. This is to incentivize, because otherwise, I mean, a distribution company might say, whatever Tamil Nadu Electricity Board would say, or some BESCOM would say that, we don't want to, because it is expensive. Let's say older plants are expensive. We don't want to buy electricity from these plants. Or if we have to absorb solar, we'll have to shut down something that is cheaper. Okay, but so we won't buy it. But we have non-curtailment policies in place to incentivize non-fossil fuel energy. And so when a large amount of this energy is available, it has to be absorbed by the grid. It's absorbed by the grid by ramping down other sources of energy. The best ramping possibilities, how do you balance the grid very, very fast? You do it through hydro, typically. Hydro is a very important resource in that sense, because it's small fluctuations in electricity you can manage through hydro. When we had the switching off the lights during COVID, as one of the things that the Prime Minister asked the country to do, there was a huge dip and change in demand, and it was managed through hydro plants in the country. Right? So there is a I mean, we'll talk a little bit more about this if there's time later. But the question is that if you don't have ramping capacity, then you have to ramp down your thermal capacity, which is basically your coal capacity. And that means you're burning coal less efficiently. So it's a bit of a contradiction here that more renewable energy is in fact leading to a certain extent, more inefficient use of coal, because you're using coal to balance renewable energy, because you don't have anything else. Because hydro is limited, it is geographically distributed. And the only other thing that can actually help you balance is gas-based plants, because gas-based plants can also ramp fast. But gas is not available with the country. So these are a lot of concepts in a very small time, I know. But what I'm trying to say is that the challenge of renewable energy, and I'm not even talking about costs yet. If you add battery, if you add the costs of storage, if you add the costs of grid integration, the costs today are not competitive with coal. When you compare solar costs to coal costs, they're typically only generation costs without storage that are compared. But that's comparing apples to oranges, because a colleague very recently said quite nicely, I think, what is the cost of solar at 8 p.m. in the evening? Tell me that. Right? So it's not enough to talk about the cost of solar without talking about the cost of storage. So they're not competitive yet. And there are tremendous technological challenges, which I think are underplayed sometimes in saying that, oh, this is a huge opportunity. Let's do renewable. Let's go renewable. But is it possible? And what are the challenges? I think must be appreciated. So I'll stop.
Thank you, Tejal. Now I'll hand it over to Dr. Bhatt.
Thank you, sir. And I would also comfortably sit here and speak, and permit me to do so. And the topic given is challenges for making climate policy. So some challenges you heard, sectoral challenges, and they were not just one, there were many by Tejal just now. So when she said sun does not shine 24 into 7, wind does not blow 24 into 7, and then you have to balance the grid. And you can take 1 minute of mine, and sir, you feel free to cut me off if I exceed 10 minutes, including this 1 minute. But say, how much would be the cost for a must-run status in a place like Karnataka, for example?
Okay, so we have done a study for the entire southern region on what is the additional cost of the must-run status policy, right? Meaning must-run is basically non-curtailment, that you have to absorb solar and wind when they are available. And that's about 15,000 crores for one state for 1 year, per year. Right? And so this is also a result, this is a result of many things also, because currently installed plants are much higher cost, right? So if you actually take the newer plants, the costs would go down, but you'd have to absorb electricity even from the older plants. You can't say that because they're old and more expensive, I won't take electricity from them. This is a cost borne by consumers, and I have a few slides on this, which I will show in the next session when we do the World Cafe. But the point is also that you have this cost. So if you have high deployment when solar is expensive, you have to pay the cost of solar. Now the cost of solar panels is going down. So cost of energy generation from solar is down, but you have to add the battery cost as the deployment of solar increases. As you have more and more solar in the grid, you need more and more storage, and you add the storage cost. So initially you have a high solar cost, which consumers have to bear. And later on, when deployment of solar increases, you have battery cost, which consumers have to bear. So it's not a zero-sum game in some sense, and an opportunity simply, as I said earlier.
Thank you. I just wanted her to add one more complication into the whole process, which she successfully did. So let me go to the bigger picture. So you have weather, you have climate variability, and you have climate change. Are we clear on all these four? If we are clear on all these four, then we are also able to understand that climate change is an additional layer of stress. And climate change is the most crucial environmental challenge. And can we call it epitome of all environmental challenges? I would say yes. And why so? Because even if you set right biodiversity, you set right your wetlands, you set right your land, or any other thing in the environmental sector, if climate change is not tackled, if you don't do that, then still all sectors of economy will still get impacted. That's how you call it epitome of all challenges. And then through 4 or 5 questions that I would raise, I would try to impress upon the challenges in policy making, especially in a global collective action problem where we are not the ones who are putting the world in a jeopardy. Our emissions, as I said yesterday, are minimal. And with that minimal responsibility, we have gifts to the world like ISA or CDRI or LEAD IT and tremendous domestic action. So where are we in this game of policy making where our contribution is minimal? It is a collective action problem. What do you do? How do you make the policy? So first of all, the question arises, do we have a policy on climate change? Do we have a policy on renewable? Do we have a policy on, name anything? So do we have policy for things like climate change, or for processes, or for impacts, or for whatever? Do we have separate policies in this country? And then, any idea how many departments are involved directly or indirectly in climate change? Government departments. So we counted once and we said we cannot take all. So we will prioritize. And you know, the priority list stands at what number? 23. 23 government departments are directly impacted by, they have their works which are directly impacted by climate change. So how do you make a policy? How do you separate the grain from the chaff? And then the question is India the third or the fourth largest emitter? Are we or are we or will we be increasing our emissions? And does the treaty provide for such a thing? So our emissions will increase. This should be clear to us. Our emissions are increasing at the rate of around 4.5% annually, and they will increase. And all this was anticipated even in 1992 when the treaty was born, UNFCCC, because it clearly acknowledges that the emissions of developing countries will grow to meet their social and developmental needs. Why? Why such a bold assertion in the preamble? Because those who have studied law, preambular is something which is factual and which is the basis. So why such a thing was there in the convention? Because at that time and even now people recognize that development is our first and foremost weapon to handle climate change. And we need to then make a policy. Now, do you want to have a policy in every sector, or policy is a mother document from which the strategies should flow? Would you call it a policy, or would it be a strategy? That's another challenge. It's not only name, but then policy is something which is overarching. And for every sector where you have these 23 ministries, means at least 23 sectors, if not double or triple. So how does one envisage a policy? So basically, we have in this country our all guidance to what we do or what we envisage to do domestically, internationally, and so on, flows from Constitution. And the overarching policy is the National Environment Policy 2006. You can have strategies below this policy. And that strategy should be what in a subject which is fraught with so many caveats. It should be evidence-based, it should be science-based. Correct me if I am not gelling with your idea at any point of time, and I am about to finish. So how should this evidence-based, science-based policy or strategy, whatever way you want to call, how it should be informed? It should be informed by, for a vast developing country like us with development deficit, it should be informed by the vision of inclusive growth for all-round economic and social development, eradication of poverty, firm adherence to foundational principles of the UNFCCC, recognition of the principle of remaining carbon budget, then rational and fair, rational utilization of the fair share of the same, carbon budget, climate-friendly lifestyles, with the backdrop of our deep-rooted cultural traditions of reverence for nature. As we were discussing, we don't view tree as just a receptacle of somebody's CO2. It has more functions. So, the broad tenets of this is endorsed when the Prime Minister says, Sabka Saath, Sabka Vikas, Sabka Vishwas, Sabka Prayas. And this strategy should be such, because today, when we speak on climate change, we speak from a position of strength and responsibility. We should be able to maintain that. And it should give hope and optimism, not just gloom and doom. With these words, I hand over back to Dr. Jayaraman, and I hope I nicely was able to fit the 1 or 2 minutes that she took. Thank you.
Thank you, Dr. Bhatt, and certainly those 1 or 2 minutes were useful, and perhaps you follow our work more carefully than we do ourselves on occasion. So I'll keep track of that. So we have time for a few questions. So the questions for all panelists, and we can start. So we will take, say, 3 questions, one after the other. The panelists can answer, then we'll take at least another 3. But please, questions have to be short, and then we can give precise answers. Yeah. Please, go ahead.
My question is to Tejal. It's a simple one. You talked about challenges in deploying solar and grid stability, integration of grid and cost, battery cost, and supply chain issues. How do you see India going about deploying at least 350 gigawatt of solar by 2030? And what are the solutions? If there are challenges, what are the solutions?
Okay, that's question 1. Question 2, Rishika.
So about the non-curtailment policy, do you think there's scope for improvement? Do you think the policy works right now? Do you think it doesn't work? And how, if you think it can be changed in some better way? And I also know that in some states, not everyone follows non-curtailment. Sometimes they do end up curtailing.
No.
You can.
One more.
This is for Dr. Bhatt.
Yes.
Could you elaborate a little bit more on your questions that you raised about whether we have policies and processes in place? What do you have in mind? What should be the ideal solution? What should we be putting in place?
Yeah. Okay, I'll add
also, do we need a Ministry of Climate Change then?
Shocking. I have a, yes.
Hello, my name is Sumit. Ma'am, my question is to Tejal, ma'am. Ma'am,
no,
how can we?
Sorry, you will get that in the next round, because we already have 2 questions for Tejal. I have a question for Dr. Rangalakshmi. You spoke about the various adaptive strategies, the broad picture. But coming to agriculture, in terms of new varieties, how we cope with stress, how prepared are we in terms of coping with agriculture stress through new varieties? What is our state of preparation? So can we go with the answers? We'll start with Tejal.
Yeah. In answer to the first question, in my opinion, we should not be putting all our eggs into the solar basket. For any country, for any region, the answer to energy security as well as sustainable development of the energy sector is to diversify the energy mix as much as possible based on requirements. What you currently have in terms of models for how this is to be done in the future. You take the CEA, they depend on the LBNL model or some of the other pathways that are constructed. They are done with the purpose to try and achieve the targets that have been politically set. They call themselves, they're called optimal pathways, but they are optimal with the constraint that you have to meet that target. But if you actually try and look at optimal pathways, you might actually get different mixes. And doing this, not assuming that India is sort of, because we are one grid, there is a theoretical possibility. If you take the most popular model for projecting how we are going to meet these targets for the future, which is by the Lawrence Berkeley National Laboratory, you see that they assume there are multiple assumptions in the models, but one of the major assumptions, which is patently not connected with reality, is that they assume that it is possible to take electricity from one place and give it somewhere else when it is required, which is not. The electricity sector is governed by contracts, PPAs, etc. And each state, like I said, has a very different demand trajectory. And we need to be able to understand that and proceed from there. Of course, the solution may also be in building transmission lines that can allow for some amount of this transfer, but assuming that all of it will be possible is erroneous in my opinion. So I don't have a solution for you, but broadly, I would say that a diversified mix, rather than saying all of it is going to come from solar, pumped hydro systems for storage, a little bit more investment. We are already looking at hydrogen, but hydrogen as storage would also be somewhere that something that we should and IGCC, integrated gasification coal plants. How is it that you can use coal, if at all, beyond 2030? If it is possible, it would be possible. That's something that we must invest in. The answer may be that you cannot use it at all, right? But if at all it is possible to use, there is no other country who's going to invest in actually R&D for this. That is one. Second is with the curtailment policies. Yes, a lot of states don't meet their obligations, right? And because they don't meet their obligations, states that actually have more renewable energy generation are forced to absorb more than their obligations. So Tamil Nadu, Karnataka, for example, are absorbing much more than what they're obligated to absorb because of the non-curtailment policies. And that is what imposes the additional cost, right? And so if you are arguing today that solar has become cost competitive, then make it compete in merit order. I mean, dispatch solar, and these are again getting into technical details of how power is dispatched. So you dispatch the cheapest source first and then the next expensive, etc. Solar and wind don't fall in that dispatch because they have non-curtailment policies. But if they are competitive, they should fall in dispatch, and you should then say, they should be sent by the load dispatcher to the utility based on if they are cheapest or not. Right? Now, if you try and do this, you still have a high absorption of renewable energy, but not as much as some states are forced to do now and incur higher costs. Again, more details perhaps later.
Yeah. So maybe Dr. Rangalakshmi, and then we come back to Dr.
Yes, yeah, with regard to the seeds, especially related to heat stress or short duration to adjust with the changing rainfall pattern or flood tolerant varieties. There are varieties which are being developed, but those are all context specific, site specific, geographical specific. But that is one part. There are few challenges associated with it in the varietal development, especially for the primary crops like paddy or wheat or any other pulses or oil seeds. But when after development of the variety, putting into the context of use, that is the long chain. So that we need to change. Normally from the varietal development to reaching the farmers, the seed system takes longer time. 3 to 4 years, minimum 5 years needed for the variety to become getting into. But before that, what changes in the climate or environment, that we need to take care. There is a challenge here. And in that, there are few innovations in recent past taken place. Those innovations needs to be understood, studied, and integrated into the existing seed systems. That is the subject of state. Each state need to be alert while developing the policies to include such climate tolerant or resistant varieties to cope with the changing nature. Thank you.
Can I say a word here? Yes, please. No, we have not developed any variety species of climate tolerant varieties considering the climate change. We have developed a lot of things, but not considering the climate.
Okay, so here.
So it is so tempting, but you are taking away the mic from one to the other. But I tend to agree with that no to some extent. But the other side is our agricultural research institutes are keeping a pace with the pests. So pest tolerance, pest hardiness is something that we have been routinely doing, and we have defied the Malthusian hypothesis by the works of such this thing, and good or bad with the Green Revolution. However, one important thing in the whole process is we always forget that we are one of the 8 Babylonian centers of origin. And there is so much of so-called germplasm in this country, which has to be harnessed to develop new varieties, new this thing. And of course, those new varieties, we have to factor in the additional layer of climate change. Dr. James is only cautioning that it is not a rose-tinted view and that everything is not all right. So he has a broader view, and more things, more of research should be done. And when that is done, we should also, as press, focus on the yield gap in this country. I mean, climate change or no climate change, if you focus on yield gap, many things can be sorted out. And that one can discuss during coffee break. Madam, your question, you stole the words from my heart when you said, can we have a new ministry on climate change? That is, so he has made me somebody there already. So, that is one way of looking. And you remember when our ministry, which was only Ministry of Environment and Forest, climate change was added. So there is a thinking in that direction. And personally speaking, that would be a very nice thing to happen for greater coordination, greater synergies, greater linkages. That maybe. And the other side of the same story is when you do this, like you did in Jal Shakti, for example. So climate change is very fashionable today, but fashions also do change often. What is fashionable today may not be fashionable tomorrow. Then tomorrow, when that day arrives, when it is no longer fashionable, hopefully it will remain fashionable. That's the presumption, climate change. But if that changes, then this whole purpose will be. So that is the other side of the point. And the third side, with coin has only 2 sides, but the third side, if at all coin has when it stands, the periphery of it, rim of it, is that all these ministries will tend to lose their own focus. Now they are glued to climate change obsessively, thanks to the whole of the government approach and efforts, all-round efforts. So everybody tries to understand, everybody tries to do something or the other. And like in policy making, like in any debate, there are debates, both informed and uninformed. That's where we are at the moment. And that's what your job is, to separate the grain from the chaff. Thank you.
Thank you. We do not have much time. I know my colleagues are signaling, but our friend here had a question for Tejal. You had a question?
Yeah.
And we'll take just one more after that if there's someone, and then we'll close. Short, please.
Thank you, sir. Thank you. Very short question. Ma'am, I want to understand how can we connect RE, especially solar's energy in with climate change in simple words. How can we connect RE, especially solar, so with climate change in very simple words, if you can define?
Yes. Any other question? Everybody is ready for lunch, but before you answer, Ranga wants a word. Yeah.
There are few varieties which are in pipeline, and it is adopted by the farmers also, especially flood tolerant varieties in many of the plains of, Assam and Orissa, even Kaveri Delta also. There are few varieties which are, and some of the areas where the minimum temperature is going down further, there the sterility is a problem in rice. So in those contexts also varieties are available. But as Bhatt sir told, the intensity of the varietal development compared to pest and diseases and climate resistance, there is a big gap that we need to push it through policies. Thank you.
I think that's a very satisfying place. Just to add my 10 paisa work to this, I've been telling ICAR that, they have all these things buried in various reports. I said, either you do it or let me do it for you. We should have a central portal where, where I said, as a policy maker, I have no idea of where we are on this. So let us put it out somewhere where we can collect it, all the information, and we have a more accurate assessment of where we are. I think that would be beneficial in all sectors, in and outside government. So, and then maybe Dr.
Yes.
Bhatt will have the last word.
Very, short answer would be that climate change is because of anthropogenic global warming, human-caused global warming, which is because of the emissions of greenhouse gases, CO2 being the largest source. And the largest emitter of CO2 is basically the energy industry, which is the fossil fuel industry, right? So you burn coal or oil or gas, you get CO2, which causes global warming. So you need energy sources that do not burn these gases, that do not emit CO2. And solar is one such technology. So is wind. So is nuclear, for that matter. So is hydro, right? And even to a certain extent, biomass, depending on how you define. But that is, so these are sources that throughout their life emit far less. They don't emit zero, but they emit far less than as compared to fossil fuel energy sources. And that is why they are a solution to climate change. Possible solution to climate change.
Thank you, sir, for that, to be able to say the last word as you coined it. But I just wanted to say in a lighter way, an important point, and that is data is one problem. And a common platform for data, as you are demanding, is one. But in the garb of that data or portal or whatever, we should not lose on having new varieties. That was my problem is these days, today, everybody gives very high-end solution, whereas in these days of plastics, missiles, or ambition to climb moon, you still depend on food. Agriculture is something which is very important. So data is well taken, but at the same time, we should have varieties and increase our wherewithal against climate change.
Okay. With these words, may I thank the panelists again. We, as usual, are behind time by 15 minutes. So I do urge you to have a quick lunch, and we'd be back at 2 o'clock. And we have one interactive session, which we will keep to time, meaning after that people have to leave. So it'll be 2 to 2 to 3:30. But I think we can make it. But please do try to make it back by, please do make it back, not try, by 2 o'clock for the next session. And as soon as you come here, we'll give you the logistics so we can start right away. Thank you very much. And thank you once again to all panelists.
So quick but sumptuous language, not short. Sumptuous.
Thanks, Sanjay.
Yeah, I'm attaching one person to each group. So I'll be attaching one group and I will just make them rounds. Second group, Sadaf. Third group, Manjeet, and now Prajesh.
Yeah.
And Charu, I'll put. Manjeet, Gautam.
We need all the participants. So we go to the in the meanwhile, we can introduce this video.
आगा भी नहीं एक दो मिसिंग है तो चलेगा बट half of the I think we are waiting for the rest of the participants. We have about half the people in the room. So we just few minutes and we'll get started. 5 minutes, hopefully, not more.
This is your notes, no?
Tejal guy.
Yeah. So you keep it with you and explain the rules. I've written the rules here. 20 minutes talk and 10 minutes. 20 minutes talk with 10 minutes Q&A.
No.
30 minutes, no, 20 minutes plus 10 minutes Q&A. 30 minutes each.
नहीं वो talk में नहीं जाएगा. I'll expect.
Okay.
Okay. Thank you very much. So we are also experimenting with this, with the World Cafe session. The idea is basically to allow for an interactive session where you can ask questions, there can be more interaction, or you can comment. And the focus really is on local level action, especially in the one on coastal ecosystems, the other on hill and dryland agriculture. So these are two which will really be focusing on local action. Renewable energy doesn't quite fit that, but it's also more about the issues of deployment, practical issues, implementation, things like that. That will be the focus. So the format, please. So I need you to be with me on this. The format will be as follows. You will be in 3 groups, which we have allocated, put you in a group at random. So there will be 3 groups. You will spend, given the time constraint, you'll spend 25 minutes at each station, which will cover one topic. So there will be 2 facilitators for each of these, or one in the case of energy, and they will put some leading questions or make a short statement about 5 minutes, no more, and then you can respond, ask your questions, you can interact, or you can take it forward in whatever way with the facilitators. Okay? So this will be at the end of 25 minutes, with each group, there will be a person who is a coordinator from our side, and they will ask you to move to the next station. So all 3 groups cover all 3 stations over a period of 25 minutes each. This is the format. Okay. Some of you may have seen it earlier, but if it is new, welcome to the club. I learned this stuff only 3 months ago. So we just have a very quick introduction of the facilitators. So Piyush will read that, and then we'll tell you the location. Okay.
Our first topic will be climate adaptation in agriculture, will be facilitated by Dr. E.D. Israel Oliver King. He's the director of biodiversity MSRF. He's an ethnobotanist and he has worked with over 25 years of experience. He has contributed to various research studies and international projects promoting sustainable utilization of crop genetic resources and agro-biodiversity conservation. His work focuses on empowering rural communities in the face of food insecurity, poverty, and climate change through on-farm conservation and livelihood enhancement initiatives. Dr. King actively engaged in the FAO-GFR initiative on forgotten foods and community practices, networking with partners across India and South Asia. Our next facilitator for the same topic will be Dr. Rangalakshmi, Dr. R. Rangalakshmi. She is Director of Eco-Technology at MSSRF. With a background in agriculture and anthropology, she has over 25 years of experience in various teams. Her research revolves around sustainable agriculture, climate change adaptation, food security, participatory research, and gender and community development. For the next topic on ecosystems and climate impacts, the coastal ecosystems, we have again two facilitators. Dr. R. Ramasubramaniam, he is a senior fellow at Coastal System Research Department at MSRF, and he joined MSRF after completing his doctorate in Center of Advanced Study in Botany, University of Madras, as a scientist, mangrove biologist in 1996. He is instrumental in executing the mangrove restoration activities jointly with stakeholders such as the local community forest department staff and NGOs in Andhra Pradesh, and restored about 900 hectares of mangroves. Our another facilitator, Dr. Velvi, she is head for Fish for All Research and Training Center in Pumpuar in Tamil Nadu. She is a scientist come practitioner and has over 20 years of experience in the areas of small scale fisheries development. She holds a PhD in marine biology and oceanography, working since 2002 with small scale marine fishing communities on southeast coast of India. Dr. Velvi has undertaken several research and development work spanning a range of issues, including coastal livelihood, biodiversity conservation, post-disaster rehabilitation, and post-harvest management. For the third topic on energy, we have again Dr. Teja Kanetkar. I think we don't need any introduction for her. She's already has a huge fan following here now. Yeah. So the rules, the rules will be explained. The groups are, so let's come to the groups. The group one will be Risika Pardikar, Disha Sethi, Gaurav Saini, Simran Sirur, Rajiv Kumar Tyagi, Akansha Desmukh. You can remember you are group one, and you will be associated with me. I will be your coordinator, and you can stay here for the first session here in agriculture here. Group two is Suchita Jha, Sabita Kumari, Mohammad Imran Khan, Nishan Saxena, Sumit Yadav, and Raman Khan. You will be coordinated by Sadaf and Charu. They will be around here. They will be taking you to the fisheries section in IGNU Hall.
Coastal ecosystems and fisheries. So
IGNU.
that's just down the corridor at the other
Our
end.
coordinator Charu and Sadaf will be accompanying you there.
Yeah, so if we can move right away.
Yeah. Our third group will be Rudran Barasu, Wahid Ahmad Bhatt, Adya Bayoni, Srishti Chaudhary, Virendra Singh Rawat, and Archana Chaudhary. You will be accompanied by Manjit and Gautam. No, with Tejal in committee room, just next to the communication department. Yeah. Third group, I will repeat, Rudran Barasu, Wahid Ahmad Bhatt, Adya Bayoni, Srishti Chaudhary, Virendra Singh Rawat, and Archana Chaudhary. You follow Gautam. Gautam will take you. Gautam and Manjit. Group one, please stay here.
Are all the participants here? Anybody outside? Could you just, in case there are people, they are starting, but people start.
Good evening and welcome back. So we'll just begin the valedictory session. And first we'll hear from Dr. Jayaraman, who will give us an overview of what the deliberations were like over the last 2 days. Dr. Jayaraman?
Okay. So, as I promised you at the outset, it was going to be a packed program. So, I think that part of my promise I managed to keep. I hope you found it of value. It gave you a perspective which we would say, however modestly, but we would say that is an overview which would not be easy to get from other sources. We do not portray our presentation, our overview as unbiased. You only know too well in the media that there is no absolute disinterested or absolute objectivity. But I think what you would have heard is an upfront statement of what we assume, what we presume, what are our values, where are we coming from, and where we wish to go. So I think based on that kind of transparent outlook, we gave you an overview of the situation as it stands at 4 scales. One is the scientific nature of the issue. The second is the scale of global politics, the scale of COP28. The other is how the national fits in. And then, of course, certainly very important in some final sense, what it means to communities and people. So I think we gave you an overview with this. It's a normal practice in MSSRF that we would have a set of key messages, but given the intensity of the program, so we would be preparing a list of the key messages from various discussions, which we will circulate among the participants, okay, and speakers, of course. I think all of us would benefit from what we got as the headline messages from each of the sessions and the discussions. There are just 2 points, I think, that were very interesting, that are of immediate concern to us as a media dialogue, as we had tried to position it. One is, of course, that we realize the need for a more structured and greater engagement from the media side. You know, the difficulties or challenges of talking about climate, about presenting climate, about taking a climate agenda forward, whatever that may mean, and how it is perceived by different sections of the media. The media is perhaps as inhomogeneous as the rest of society itself. So that, I think, we just sort of barely scratched the surface in one session, but perhaps we should pay a little more attention to it as we go forward. The second thing is, and I think that's very interesting, perhaps even curious, that these resource persons and speakers were quite engaged with this opportunity. And yesterday you heard there were suggestions to upscale this, something to the level of in-depth media briefing of this kind. You know, there are in-depth media briefings going on all over the world by all kinds of agencies, but an in-depth media briefing of this kind that we had, perhaps more focused on the international and global politics, political economy, etc., which we didn't quite touch, of climate change, which would be of value to COP28. And in fact, even as we ended that session, there was the suggestion was made publicly, and I got messages following up on that idea. So that perhaps is something which we could look forward to, and perhaps we will, I think, engage with that idea quite seriously. These are two important takeaways we got from the interaction. Once again, we hope that our comprehensive coverage of issues is of value, and if we will circulate a feedback form. Okay, so I was not very sure how we would handle it, but we will circulate a short feedback form or a link where you could make your provide your feedback, and that would be of value going forward. As for the rest, thank you very much for being here. And we got as much talking about things as I hope you got from us. Thank you.
Thank you, Dr. Jayaraman. We'll now hear from Dr. Sami. Would you like to do the certificates first and then give a valedictory? Is that easy? Yeah. Okay. So then we'll have the certificate distribution then now. Yeah. Gautam, please. You want to make the announcement?
Nishan Saxena. Shuchita Jha. Archana Chaudhary. Rishika Patikar. Sabita Kumari. Rajiv Kumar Tyagi. Sumit Yadav. Gaurav Saini. Ramankant. Adya Bayani. Akanksha Deshmukh. Disha Shetty. Simran Cyril. Virendra Singh Rawat. Wahid Bhatt. Rudran Barasu. Muhammad Imran Khan. Srishti Chowdhury.
I have a very short clarification which I thought could be taken for granted, but I was reminded that perhaps not, and I did not sort of get the opportunity to make it clear. All that is discussed in the sessions, in the question and answer, within the purview of this workshop, is for you to use as you see fit. Whatever we have spoken here as part of the workshop or this dialogue is on record. So this is absolutely clear. So there is no discussion about it. As our friend Mr. Ram said, if you hold a media workshop and you don't want anything to be carried in the media, then don't talk about it. So whatever we said in the workshop is for you to use as you see fit. We would, of course, appreciate the courtesy of checking back if you wish to do so for accuracy and rigor. However, this does not, I think, cover conversations outside in terms of where we congregated over tea, coffee, and dinner. But everything in the workshop is for you to use as you see fit. Thank you.
Yeah, thank you, Dr. Jayaraman. I think that was an important clarification. So I hope that you've all enjoyed these 2 days. The media colloquia used to be a regular part of this foundation's right from the inception, because the science and society linkage is very much part of the DNA of MSSRF. And the science and society linkage definitely means that communication and dissemination of scientific information is an important part of that. Otherwise, you can't have that linkage. And so I think the media of all types, of course, today we have media, not just a traditional media, but many of you are, independent writers, people write blogs, and there are so many ways of disseminating information today that were not there earlier. So I think the whole concept of media also has changed a lot in the last couple of decades. So we decided that we must restart this, the regular sessions we used to have, at least a couple of media dialogues every year on contemporary topics. So we thought climate change definitely is not only contemporary, but also with COP28 coming up, as well as all the work that's been done in the foundation, we thought it was a very good topic and a good fit, perhaps, for the first one of 2023. But we hope to have more of these. We also are very happy that we have got journalists from all over the country here. I think there's a very good geographic distribution as well as a gender balance. So I'm very happy about that as well. And we always try to maintain that. And in fact, we would like to reach out even more and get people who are really from far-flung areas where there may be even less access to information compared to journalists who may be working in metro cities. So it's nice to see many of you coming from different parts of the country. The goal would be, of course, to see an increase in the outputs related to this topic, hopefully in a very informed and a mature analysis of the issues. As you pointed out, there are many nuances here, and it's not always straightforward to interpret the data or to read those reports which are produced by the scientists. They're very difficult to digest even for other scientists because they run into hundreds of pages. So I think those of you who are interested in this topic are obviously making a big effort to educate yourself and be well informed so that you can then inform your readers. It's also important, I think, in India, really the language issues also very important. So we don't want to be only addressing the English language media. So again, it's really good to see people who write in different languages so that we can reach people. I heard some of the discussion and the Q&A, which was really very interesting, but I'm sure that the 2 days were extremely rich. Perhaps you still have a lot of questions, I'm sure, which would need to be answered. So as Dr. Jayaraman said, I think perhaps for some of the topics, we may have scratched only the tip of the iceberg. There may be much more to get into in depth. So I'm sure that all of us would be available. The scientists at MSSRF would be available to you and accessible to you. You have our contact details now. You can reach out through Sangeeta if you like. If you're doing stories, if you want to check, if you want to get more details, or at any time in the future, if you're doing stories that are related to the work of the foundation in any way, whether it's biodiversity or fisheries or farmers. We heard about the agromet advisories and so on. Maybe Dr. Ranga would have talked about that and the work that's been done both using digital tools for farmers as well as for fishermen in empowering them better. Gender, the work that's been done on empowering women, apart from the work on health and nutrition security. So any of these areas, please do reach out. There's some information on our website, but if you need more, don't hesitate. I think we're always happy to help you. And also do send us your suggestions. The feedback form, please take some time to give us your feedback and suggestions on how we can do this better. And also suggest topics. Please feel free to suggest topics if you think that the journalists do require, discussion. I remember long ago we had one on GM foods, and that continues to be, I think, a topic of hot discussion even after so many years of the pros and cons and the benefits. Similarly, there'll be many other areas like this where you want to discuss. We do want to see more and more science stories in mainstream media. I think one thing the pandemic did was it did create interest and curiosity among people, at least on the health side. I mean, now everybody knows what is a virus, everybody knows what is a viral sequence, what is a sequencer, a genomic, this thing, what is a variant, etc. People, all those terminologies have become common, whereas earlier nobody would have known or what is a clinical trial or how is a vaccine developed, etc. So that way, I think it opened up the common person who was listening to the news or reading the newspaper started hearing about many other things that happen usually in the background, but they came to know about it. So I think it's a good example of how when there is some topical, you can leverage that and make use of it to really explain how the science works. And somebody this morning was asking a question about scientific literacy. I think it's extremely important. And in our country, I agree with whoever asked that question, that scientific literacy still needs to be improved, and particularly starting from school, because that's when the foundation is laid. But if you see still the number of people who believe in rumors and believe in superstitions, it's significant. And therefore, rational thinking, critical thinking, scientific thinking, all these are really important, particularly for our children. As they grow up, then they will imbibe those skills for the future. So again, thank you very much once again, and we'll do feel free to reach out to give your feedback on this program, but also suggestions. And if you're writing stories and you need help, as Dr. Jayaraman mentioned, I'm sure the faculty members would be happy to answer your questions or give you more information. Thank you. Thank you very much. And thank you for all of you for coming here and spending 2 days. And really, I think it was a very interactive and vibrant discussion. Over to you, Sangeeta.
Thank you, Dr. Soumya. Before I go ahead with a formal vote of thanks, I just want to say that there's a Google Drive with all the information and the inputs, the articles and everything available for you. And we'll share this with you and give you access. I think some of you have already got access to it. So even your questions, I think even the feedback form will come through the Google Drive. So you can use it as and when within a couple of days so that we can receive feedback. Okay, if there's anything else, please feel to reach out to us. So so I have the pleasure of presenting the formal vote of thanks, and there's a long list of experts to thank, and I hope you'll indulge with me in just giving a little more time so that we recognize them. So it's been a learning experience for both, I think, the journalists and the scientists, as Dr. Soumya and previously Jayaraman and Dr. Hariharan had specified that we are restarting this kind of engagement with media in terms of especially looking at how we could learn from each other, and also looking at how we could share science-based evidence so that the reporting is more informed. So given that, I think with COP around the corner, this was very timely planned. And we had several good speakers, starting with Mr. Ram, who drove home the point of the credibility of information that we share with the larger audiences, irrespective of which medium we choose to share our news through. And also then we had Dr. Arvindan Natarajan, Mr. Sandeep Mahato, and Dr. Tejal here who have been like common names now for the last 2 days. And they have explained the science behind climate change and several concepts and provided insights on the IPCC. Thank you for that. We also had a deeper delve into the global agenda on implementing the UNFCCC and its Paris Agreement. And there was a twist given to the financial side of it by Mr. Indrajit Bose from Cannes International. Thank you for that insight. We also grateful to Dr. J.R. Bhatt. He spent about 2 days with us, having walked through the entire process of looking ahead to COP28, along with Dr. Tejal and Mr. Indrajit. And we had Dr. Diago, Ms. Meena, and Dr. Andrew, who joined us online to share their perspectives. Following that, we also looked at the impact of climate change on India specifically. And this was explained very well by Dr. R. Krishnan, and Dr. Soumya again spoke on the consequences of climate on health, human health, and thanks for that enlightenment. We also had Dr. Ramachandran, who ruffled the feathers a little bit in terms of asking us how do we cope with uncertainty and probabilities while reporting on climate change. I think that evoked a lot of emotions in terms of journalist reporting and stuff like that, which was quite interesting. And I think that was very important. And that's when I think we as scientists here learned from the other side as journalists what you expect and where your limits are also in terms of reporting. We also had a panel discussion that brought out challenges and opportunities for water, renewable energy, agriculture, climate policy, etc. And we are grateful to Dr. Rangalakshmi, Dr. James, Dr. Tejal, and Dr. Bhatt, who managed that session. Going a little more local, we also looked at the regional climate action, and we tried out the participatory exercise. I think for the first time, we've tried to do a model of a World Cafe here and the breakout rooms, and the 3 sessions on climate adaptation, agriculture, anchored by Drs. Oliver King and Rangalakshmi, energy and development topic anchored by Dr. Tejal, and the coastal systems topic that was handled by Dr. Ramasubramanian and Dr. Velveli. I think the discussions turned out to be very informative and interesting is what I gathered from the feedback. And we also want to recognize that this media dialogue is supported by the Third World Network and Climate Trends. We are grateful for their contributions. So we also extend our gratitude to the Executive Director of MSSRF, Dr. Hariharan, and our Chairperson, Dr. Soumya, for agreeing to stay with us till the valedictory. And last but not least, Dr. T. Jayaraman, who's been a steady anchor throughout the media dialogue. And of course, the climate change and communications teams at MSSRF for having worked together to make this program successful. Over the last couple of months, this has taken a couple of months to package, by the way, because you've been applying it through the process of selection, etc. So there's been several moments where we had to blow off a lot of steam, but yet we came back together and worked. And I think that shows our commitment and resolve to engaging with the media and also on the topic of climate change prior to COP28. So I think this is our first restart of our several dialogues to come. And I just want to say that this is a continuous initiative, as Dr. Soumya has also mentioned, through the Media Resource Center that we have, which is with a specific mandate to linking science to society. So we intend to engage with you journalists for longer periods of time, both in India and also spread far wide through the global south. So thank you very much again for participating and for your cooperation and understanding, and have a safe journey home. Good evening. Yeah, we'll have a tea served outside at the pantry. So kindly join us for some tea before you depart.